All right. Well, let us get kicked off. A warm welcome to everybody. Oh, hang on a second. Yeah, welcome back. So there's some familiar faces. Oh yeah, and Jeff. Wow, there's some. Yeah, there's some. This is a lot of fun for me because yeah, some familiar faces, some new ones as well. A warm welcome. My name is Adam Hems. I'm a cloud. My day job is a cloud architect with Microsoft. But this is one of my favorite hobbies. Actually, it got a lot more fun being back in person. I've been running this since 2015. I took over the group. The group's been around since 2003, and I joined it in 2015 or about 2014 or so. Some of you have been around long enough to remember that. And I think the most recent meetup was at a brewery. And they were just, hanging out, and they looked like fun, but it wasn't very technical. And so I pinged them and said, are you guys doing anything? It'd been 9 months, and he said, yeah, I moved to Florida, so hey, you want to take it over? And I said, okay. So all right, fine. And so I took it over, and Microsoft lets me use the office here, so that's nice. That's good. I try not to compete with AWS. A lot of members of our group, that is the AWS. Am I pointing the right one?
Yes, you are.
It is that one, yeah. AWS have their offices over there, and they have a meetup. And there's a lot of members of the group who are also members of that. So try not to conflict with that, because I mean that's reality. Tuesday night. Yeah, it seems to vary. I'm a member of that group. I've been out there. They have beer. Have you seen that? They have beer. We're not having beer. It's not on tap. There are some cold ones. So we don't do beer here. We could, but it's a lot of hassle, and we need a bartender, and it's a lot of work. So no, not doing that. Not doing it. You get pizza, and courtesy, in fact, of Avanade this evening. So thank you to Avanade for funding the food tonight. Yes, thank you. Josh is here from Avanade, and so is Michael, also Avanade. Yeah. Thank you, guys. I really appreciate it. Thank you for sponsoring our community. So what is this community about, right? So for some of the new folks here who haven't been part of us a little bit, this is an opportunity for learning from one another, right? I engage in my day job with talking to a lot of customers, and so do many of my colleagues, and so do many of you, right? A lot of consultants, a lot of folks who work with a set of technology and solve a lot of the same problems, kind of one-on-one. And it's within the companies that you work for, with Microsoft, solving the same technologies, going through the same problems, but there's not usually much of an opportunity to learn from other companies, other people at other companies who are going through the same journey, maybe different industries or even the same industries. A lot of oil and gas folks who come to this meetup from varying experiences, levels. We got students coming to this meetup to learn. Their professors send them out here just to learn. And it's also actually a key part of this job. We've had recruiters come, so I don't know if there's any recruiters in the room, but you are more than welcome. In fact, I encourage folks to post job postings on the homepage of the meetup, because that's part of it too, right? People looking for new and better jobs, because I think those of us who've been in Azure for a while know that there's a lot of demand, right? A lot of demand. So that's also part of it, right? Helping folks network and get better jobs as part of coming to here, and fundamentally to learn. So we're here to learn. Not so if you're looking for a sales pitch, definitely the wrong place. That's not what this is. This is about learning, and some of the best presentations have been from members of the group. Those are the ones I think that have been the most fun and interesting, where true war stories have been shown. This is what we're actually doing, what we've learned. This is how we're using those technologies. Those have, I think, been the best. Get a lot from Microsoft consultants, my colleagues as well, partners, a lot of diversity in presentations. And I don't usually actually treat myself to speaking. This for me is an absolute treat. I'm indulging myself something rotten here. It is yeah, so this is only, I think, the second time in a couple of years I've allowed myself the privilege of this, because I frankly like it so much. I could do it all day, but no one's here to be no one wants to be there. Well, anyway, okay, I'm indulging myself by presenting on one of my favorite topics, in fact. So I've been working with Kubernetes well, about 3 or 4 years, I would say now. And so this particular topic is just one that comes up so much that I thought, okay, fine. Well, I get so many questions on this all the time, and more questions around AKS, Kubernetes, and there's other Azure services. There's a lot of container options. In fact, we've had some talks on the container options, and we probably ought to have another one because there's new services like container apps that went GA just today, in fact. Yeah, so that one's a pretty popular alternative to Kubernetes. One of the reasons for that is because it is a lot simpler, as you'll see, than Kubernetes, but has a lot less features. Not really going to talk about that one today, but Kubernetes is certainly on everyone's mind. We have a lot of customers to talk through this. So anyway, that's what I'm going to talk about today. So yes, James.
I'm studying Azure DevOps and CI/CD and the whole deal, but I have an idea of my own private needs. It will be developing an app on iOS and Android and whatever, running mobile app. I'm here to find out what is exactly Kubernetes. I've heard a lot about it.
Okay.
Why should I get involved with it in developing?
Why should I care as a developer, right? Okay, yeah. So that's another aspect actually that I've seen a lot. I've been doing in this role for 7 years, and something else that I'm going to talk about. I work with folks, so I know there's some developers in the room today. We've got infrastructure folks. Any infrastructure? Jeff is infrastructure. Yep. Couple of folks online who are infrastructure. Yeah, I'm not in the camera. Sorry, everyone. Okay. I did turn off their mic, so I have to listen out. So, okay. Developers, infrastructure. We also have security-focused people. Jeff's also security. A couple of security folks. Okay, welcome. Yeah, and so DevOps. James is more DevOps. I think he tends to be more of a focus all by itself to some extent. Okay.
Build a mobile app.
Yeah.
Myself and
right, and and the expertise like networking is often any networking professionals.
That would be me.
Okay, your network, yeah, of course, your networking, yeah, right, indeed, yeah, and so deep expertise in those areas, right, and then that naturally forms, particularly bigger customers, a lot of silos, right, of expertise. That frankly, services like Kubernetes just crosses all of those, which is actually one of the largest problems with it, because it exposes the silos that every company has silos of expertise, of infrastructure, all the way from security folks at one end to the developers, to James' points, almost at the other end, and the DevOps that's enabled for all of those. And so that exposes, honestly, some complexities and some weaknesses. There's some arguments. There's some pain, right? So I'm actually going to talk about some of those things. To James's question about why should I care, and I was talking to someone earlier, developer. Who was I talking to? I forget who I was talking to. But around the new guy. Where'd he go? You. Yes. You at the back. Yeah. Yes. Josh, right? Yes. Josh is a developer. He's new to the group, everybody. Everyone welcome Josh. First time in Houston as well. So, yeah. So James.
I'm ready.
And you're, that's right. James is brand new. Well, welcome. And so Josh is a developer and is also new to AKS, right? So, and that's a common thing. AKS is a lot of Kubernetes, a lot of infrastructure traditionally. So as a developer, why should I care? And that's actually an important aspect of it. There's traditional silos whereby as a developer, I don't care. Let someone else focus on infrastructure who knows Kubernetes or whatever it is, who cares, virtual machines, learn all that junk, stand it up, get it configured, get it right, and then I'm just going to write my code and deploy to it. And eventually that's the goal. Actually, that is really what you want, but some knowledge about what is involved, all of that, is an important component of success. So we're going to talk about that too. It's not, in other words, this isn't just for infrastructure people or networking people or developers or DevOps. It actually encompasses all those roles. There should be something in here in my discussions with customers around this topic and this solution and best practices and things like that. It's should be something for everybody. So, all right, so that's what we're going to talk about tonight. Make sure, all right, let us go through. So I've broken this out, a set of areas of focus, and this is, I've summarized it. I've stolen content left and right, very little new content in here, right? Much of this I'm pulling from stuff we already have, going all the way from the strategic, the very large scale, which again, everyone, generally speaking, in my experience, should have some awareness of, I think, all the way to actually the desired ultimate state of developers just get on with their job, write some code, and an automated CI/CD pipeline does its thing, and magic happens, and it's thrown on the infrastructure, which is itself then fully automated. There's still some care and feeding of that thing required, right? But getting to that is actually the walkthrough, the areas of discussion we're going to have. And much of it, I'm just going to point at stuff it's already out. We've got there's no new content. I don't think anything. There was a bunch of stuff announced at Build today and will be tomorrow. None of that really plays into this. It's fairly general, and there's a lot of weeds. There is a lot of weeds with AKS that I'm going to resist going to. If you've got questions, then we can dive into those. But generally speaking, I'm going to try and keep it relatively high level, right? I'm recording this, so you can watch the recording afterwards. I'll share the deck. It's fairly lightweight, but anyway. So enterprise scale landing zones. Does anyone know what enterprise scale landing zones is? Familiar? Jeff's no idea. Some shaking of heads, blank stares. Okay, that's good. In that's part of explaining what that is. We'll dive into absolutely. Yeah, please. Yeah, it must. Yeah, but we're all just going to wait. And we're going to. Your friend is going to come now. I'm just horsing around. Yeah, of course, absolutely. Yeah, this is we're all here. Get him to join though. I mean, that'd be good. Have him. Yeah, it's fine. Yeah, there's sign up isn't required on the Teams link. I opened it up so it's anonymous. You don't have to sign in, so you don't need an account or anything. I'm going to get extra points. Extra bonus points. Yeah. For this man, extra pizza. We have plenty, I think. All right, and then so the enterprise scale overview and landing zones is strategic, right? It's important. It's where this component and frankly a lot of other components we recommend we put it, right? So it's not, and again, something everyone should really have an understanding of. Then we're going to touch upon networking components. Again, we could go really into the weeds on some of this. I'm going to avoid going to touch upon some of the things that you should know, that some of the best practices, because even the documentation for AKS, it will say, hey, you can do this, or you can do this, or you can bring your own. It doesn't actually have an opinion necessarily around, well, if you do this, then there's not that much opinion, if you will. More of you can do this, and what you pick is up to you. Have fun, good luck. So going to have some opinions in our discussion today to help provide some guidance. That's frankly, we don't have enough of that really. We're going to talk about another framework that pertains. Is anyone familiar with the well-architected frameworks? That ring any bells? Couple of nods. Probably a bit more familiar to more folks. That one's smaller in scope. We'll talk about that because again, something that irrespective really of your role, developer, infrastructure, solution architect, or just trying to understand what the heck all this stuff is. You need to know what the WAF is. Well-architected framework. Then OTT on the TLAs. LOL. Okay, fine.
Security. So
The web application firewall. Yes, we are going to talk about that. There is one of those in some of the diagrams that I'm talking about. Yeah, you're right. That we do have far too many TLAs. And then there's actually a reference implementation we'll talk about. So if you want to see how best to do it, then we actually have one of the best practices is infrastructure as code, which is basically not using the portal. So we're going to talk about that as well. And then the last steps, CI/CD, right? How you, some approaches that you would need to take in order to get whatever your application workload is onto one of these things. It's all very well having one stood up. What's one of the best ways, or some of the options, or some of the considerations for enabling that? All right. Okay, sound good? Any questions or anything that anyone else would like to see or they came here to learn about, or just here to learn and try and digest? Yeah. Okay, here to learn, here to digest. All right, sounds good. Well, you're in the right place. So one thing I'm actually not going to talk about, which I can, if you wish, is something, some of the basics of Kubernetes. Do you want me to cover what Kubernetes is? A level set might help. Does anyone not know much? Yeah. You could use some an overview of what Kubernetes is. Yeah, what is Kubernetes? Yeah, all right, fine. Yeah, let's start with that. It was announced in 2014, so it's pretty new, right? It's a bunch of software named. It's a Greek name, Kubernetes, that relates to navigation or steering, like captaining type Greek name. And the purpose of this software is to provide a mechanism for orchestrating containers. So again, I'll cover containers briefly. So many of us are familiar with servers, and then we virtualize. I remember the first data center I worked to after right out of college in the 90s had bare metal servers in it, racked and stacked, compact. And then in the early OOs, VMware invented virtualization, and then you're able to pack more virtual machines, OSs, and Linux onto those physical hardware, pack them in the entire OS, so they would boot independently.
Actually, can I add a little caveat to that?
Yeah.
It was 1964. IBM actually invented virtualization.
Okay, I stand corrected.
And I had to learn it to teach a class.
Okay. So VMware did not invent it, but they came out with the software that really took the world by storm in the OOs and led to what modern IT now considers virtualization. And then containers are very similar to virtual machines in that it's a semi-virtualized way of containing typically an application that to the application looks like it has an entire server to itself. It does not, because it shares the operating system with the other containers. Not that it knows that so much. First created with Linux, became available for Windows in 2016. The benefit really of containers or virtualization is same physical server, so however many cores, you can pack more applications on it or more pieces of applications onto that piece of hardware. That's why we bother. Also, there is some portability to that too, right? So containers can be moved as long as you have something that runs those containers, and there's a lot of options between wherever you want. Different clouds, on-prem, physical machines, bare metal, virtual machines, lots and lots of easy ways to port your containers around. So build it for a container once, run it in lots of places. The problem that Kubernetes actually worked to solve is, okay, we have a lot of containers now. It became very prevalent, very popular. How do we manage all of those things? How do we, if a piece of infrastructure running underneath my container dies, then how do I deal with that? Traditionally, somebody alerts, go in and fix it, change out the hardware, redeploy the containers in the most manual way you might expect. Surely we can have some automation for some of those things. And that's essentially what Kubernetes provides. It's some orchestration software to help, if you're assuming that you've got your application, whatever it is, your programs, your software, containerized, provides a mechanism and a set of tools to manage deployment and operation of those things. Really what it does. It was announced in 2014, like I say, created by Google. and released immediately to open source in 2015. So relatively new, a short 7 years that it's been out, and then has been lots of distros, lots of versions of it, all to the same basic spec. So lots of software vendors have built flavors of it. Some you can purchase. Azure Red Hat OpenShift, for example, is fully supported, all built on Kubernetes, and smaller ones from the makers of Ubuntu that runs on a small Raspberry Pi. So from giant to teeny, lots of flexibility and choice, Linux and Windows. Now, AKS is Microsoft's flavor of Kubernetes. So you can just install Kubernetes. It's just, again, a bunch of software and just install it on virtual machines. Just pick your flavor of Linux or Windows, pick the right flavor, deploy it, and there you go. So you can put it all on virtual machines if you want. That'll work just fine. There is some care and feeding because there's quite a lot of components there. It's quite a lot of work. AKS basically does that work. Installs Kubernetes. It's still full-blown, fully open source Kubernetes, not Microsoft flavor of Kubernetes, fully open source, which actually is an aspect that we'll come to. That's a problem. That means you need to manage it, in fact, maintain the versions of Kubernetes on this thing, something that container apps remove the need to do. So that's one of the complexities that this brings to you. Helps with some of the infrastructure. We're going to talk about that as well. So yeah, provides the infrastructure, installs Kubernetes for you, and does a lot of the work. And in fact, installing Kubernetes, which I'm not going to show, is a one line. Well, actually, I might as well, because honestly, this is can't see, getting old, need my glasses. Say again? Kubernetes. Did I misspell Kubernetes?
No.
So there is Azure AKS quick start. I'm going to just show you. There it is. I just bingled it. Bingled Azure AKS quick start. And here it is. Not going to demo. But see, I'll just walk through it very quickly. What we need to do, which is not a lot. You can see a sample app you can get up very quickly because it's already in a container. So you need an Azure subscription. A freebie would do just fine, and it walks you through a few steps in the portal, some examples that you need to pick. Actually, if you use the Azure CLI, it's even quicker. Yep, it's the CLI. So this is the command line tool. A few components that you need to check. Basically, there's two main steps. Create a resource group, which is a logical grouping of resources in Azure. So AZ group, AZ is the command line you can run from Linux or Windows. In East US, give it a name, and then it just creates this logical container, which you can use for securing things, grouping things together, keeping things tidy. And then you create the cluster, which is actually one line. This is how you create a Kubernetes cluster in one line, like that. So it is very straightforward. In that one step, you'll get a Kubernetes cluster, and I can show you one if you would like. Let's see. I have one pre-set up. I wasn't actually intending to walk through the demo, but I want to show how to get a Kubernetes cluster stood up, and then you get some resources that look a little bit like, let's see, here's my Kubernetes cluster. So it's just a resource. There's a bunch of settings, node pools, 2 node pools in here, each a set of virtual machines. So this, at its base, most simplest, this is where the containers live. They're just virtual machines, essentially like any other, with some software pre-installed upon them. We call this a cluster because it's multiple virtual machines that all work together. And the way that is done is through Kubernetes. It's Kubernetes that makes these work together. Node counts, so two nodes. So I have 2 Linux nodes and 1 Windows node in this. Actually, yeah, 1 Windows node. And you can see the family of virtual machine is laying right there. And that's the infrastructure. That's it at a very high level. You can create this with a simple command line. And it has just a ton of settings, which I'm just gonna move past the details, right? Give you an idea of what it looks like in the portal if you were to create it in the portal, and how to create it in the command line. Now, everything I just showed here on that CLI right there, don't do that. Do not do that. I'll use an analogy here. It's great for demos and examples, and you want to just play with it maybe in a Scratch subscription, but don't, honestly. I've actually given this feedback to the engineering group, because the problem is that people will see that quick start, they'll create one of these, they'll get a resource that looks just like the one on my screen. Okay, I created some resource, and then they'll talk to I am the developers and go, right, you got your containerized stuff. Yeah. Okay, there you go. Set up some DevOps and throw it on there. I mean, there's some nodes there. They're pretty decent. This one's however many cores we picked, however much memory we've got, we seem to have enough. I enabled to throw apps on there and see if they work. And guess what? They will, because they're in containers, and it'll work just the way the developer did it on his or her laptop or machine. And okay, well, that was easy. Actually, it's just great. Fantastic. Okay, well, that was so easy. I guess we're pretty much ready. We'll do some more testing, scale it in, tweak around with some of the stuff on the portal. We'll mess with it. But honestly, seems great. Let's just go to production. Okay, why not? Yeah, fine. We're going to do it. Fine. All right. Create another one in the same way. Change the name. Maybe call it production, something like that. Pick the region. Maybe pick bigger virtual machines because it's now production instead of dev. Throw the stuff on there. Throw the code on there. Good to go. Problem solved. We are now in production. And then the security folks or the networking folks might come in and go, well, this is kind of internet facing. Do you mean to do that? Well, that's the way it came. How else are we going to do it? Well, it shouldn't really be internet facing. It needs to be internet facing. No. Okay. And so essentially what happens is that there's a lot of security considerations that in that one command line that I was showing you earlier are not enabled at all. There's loads and loads of locks and choices and features and capabilities. Some of them deeply technical. We're not going to go into those, but others that just, okay, yeah, we shouldn't have it internet facing, that are just not enabled by default. Not there. And if they were, then it wouldn't be one command line. It would be a lot more than that. Now, there are some more choices lit up by the portal as well, so that can be good. But again, the problem with the portal, well, all right, I'll ask the audience who has an opinion on any problem with using the portal. Loaded question. Any thoughts? Yeah, go on, Jeff.
There's a lot of features buried in configs in a variety of ways that we don't have any access to anymore. There's a lot of things I can set it up through the portal to learn what it looks like, and then go to the docs so that I can see that I can set up this kind of networking, this kind of firewall, this kind of living in my world, but 100 other things that can get rapidly out of hand if the person that knows the most about Kubernetes is the security person, but can also go the other direction where it can become overwhelming if you aren't building on each stage as you're walking through designing that multi-line command that you want to deploy.
Yeah. Yes, partly. I'll go further as well. There's some other aspects too. So yeah, I agree with you. Other problems are, like, for example, the nice pretty one I'm showing on my screen. The portal is absolutely great for monitoring and viewing. Should use that. Use the portal absolutely to look at resources you've created, see how they are. As a monitor, as a bunch of features like we're looking at now to see the configuration of the thing after it's been deployed to production. That's great. Problem is in using the portal to create things. Problem with that is, well, like pick this example right here. Adam, how did you create that? What were the settings that you used? Can we have another one? We want one exactly like it. Can you clone this one or something like that? Answer is no. No, we can't, not very easily. What settings did I use? Well, if I use the portal, unless I took lots of screenshots, I don't really have a good way of recording what I did. And as we perhaps already know, the portal changes a great deal all the time as new features come out. And the screenshots I took, a couple of weeks ago wouldn't match with any more. So the analogy I use with the portal is, let's say you are learning to ice skate or to bowl, right? And I am your instructor. If you say, okay, Adam, you know what? I want to go professional. I want to be a professional ice skater or bowler, whichever your preference is. It makes no difference. The analogy is the same. I want to do both of those, and I'm your instructor. And we might go down to the skating rink or the local bowling alley. And okay, well, let's start learning. And you might reach for the rental skates or the rental balls because that's what you're used to. And I'll go, no. We're going to do this professionally. So we need to take you to the pro shop, right? We need to get you the pro skates measured up, maybe some different kinds, different types, metals for the skates, and some proper gear, custom bowling balls, different ones, bags, outfits, things like that, special shoes. Special gear from the pro shop because you're going to be doing professional right now. And so the portal is like reaching for the rental ball. I mean, it's okay. It's a place to start. It's all right. Place to learn, place to create things. But if you're going to do it professionally, don't use the portal. Use the command lines like we saw earlier, or better yet, infrastructure as code. So that's a description of how you create these resources as a template JSON file. Use that. Because you can repeat it, because you can check it into source control, so you can see what was created and when and how, what the state was, the versions, the APIs that we used at the time it was created. And if I want another one, exactly the same, I can rerun the exact same scripts and I will get the same result because I'm using the same APIs. Even if the service has changed, new features have come out, the scripts are versioned, and so they have versioned APIs. And so we're going to get the same results by running the same scripts each and every single time.
So is it the script combined with JSON?
The scripts are JSON. Yeah.
Oh, scripts are JSON.
Scripts are JSON. Yep. We have some examples I can show you. And that's how I actually created the one we have on screen. You wouldn't know that because the end result is the same. If you use the portal or you use this command line or you use infrastructure as code, the result's the same because it's still called the same Azure APIs. You get infrastructure. There you go. But the mechanism that you use, it matters. Infrastructure as code is the way that you should do it. So, and because not everyone, there's a learning curve, right? That's why one of the reasons I like the rental ball or rental shoes analogy. It's easy. I don't know. I have to go, Adam. I just don't want to have to go to that much effort, learn all that stuff, spend all that money on that time. I'll just grab the rental skates, hop on the ice, and do some spins. Right? Will that work? Will the result be the same? Yeah, sure. You can still skate doing that, right? But if you don't want to make the investment, but you're never going to be as good as if you make the investment on going to the pro shop. You had a question, sir?
Same for
Templates are a form of infrastructure as code. Yes, there are 3 different types commonly used: ARM templates, Bicep, and Terraform. Yes, ARM templates good, portal bad. For creating infrastructure. For viewing infrastructure like we're doing now, the portal's great, absolutely. That's what it's good for. So okay, yeah, ARM templates is one. Oh, did I miss a joke?
No. It's not like ARM template's good. Portal bad.
They are, yes. All right. Okay, so that's actually one of the best practices that we're going to talk about, including the networking and best. So I took a side journey there because I was listening to some of the experience folks have, but let us get back on track and continue on. So all right. Okay, so actually I'll We're talking about some of the best practices. The reference implementation that we're talking about here, that is infrastructure as code. That's sort of why I got sidetracked into the portal and the problem that can be created by running that simple command line, right? It doesn't follow any of our best practices that we, the recommendations, but we have a reference implementation, which is, and it includes some ARM templates, some Terraform, some bicep files that does include all of the best practices, and there's a lot. There's quite a few, and I'm going to touch upon them. That's just to give you an idea of some of the things that that you should know. And if you have questions, interrupt. This could go very deep. I'll try and resist because we have a lot of areas of complexity, particularly networking and security. We'll try and stay high level and not get too buried into the weeds because others won't find that as fun and interesting. But I'll link to some documentation and we can answer questions later if you like. Okay, first thing to know about is a sort of a set of guidance and best practices called enterprise scale. So it's an approach to architecture and a reference implementation all out. None of it's a secret, none of it's new. You don't have to pay for any of it. It's a set of documentation. There's a lot of it. I will show it to you in a minute of guidance for enterprises, small and large, who are looking to move to the cloud or between clouds, actually, from on-prem. So, how do I, right? What are the best practices? Assuming that I'm, there's a beginning and an end typically to a cloud journey, right? Beginning would be some kind of on-prem infrastructure in a colo. Some customers who have closet literally in the buildings that they work in. Others have entire buildings. Some of the customers have, or they have their own data centers. Some of the large enterprise customers build their own buildings, fill it full of thousands and thousands of servers. So that's the starting point, the beginning of the cloud journey. The end of the cloud journey typically don't have any of those anymore. Just networking on-prem, right? And all those servers are virtualized and running in Azure. That's a long journey, many years for most customers. Not usually something, well, okay, not usually, can be quick, but if it's quick, then that probably means you're not following this guidance. In fact, it can be done quite quickly, but not necessarily properly or to the best way. This guidance is about how best to do the entire thing. And I'll click on this reference implementation again, just to give you an idea of some of the stuff that we have. This is set of GitHub repo with a whole bunch of infrastructure as code. So that was what we were talking about earlier in Bison, I think, and guidance that steps you through things called landing zones, which we're going to talk about in a little bit, and a big diagram here of all the components about how best to do it. So I'm going to talk about what these components are a bit more in a bit, but there is the point of showing you this is to give you a sense, an indication. We don't have time to go deep into this. Know that there are some patterns and best practices that we recommend that cover not just technology, right? It's not just how to configure the networking. That's straightforward, or can be, but also the governance, right? Or even how to arrange the people. What teams should the people be in your organization? How should they be broken up? What responsibilities should they have? Away from the traditional silos that you'd have on-prem. There's obviously a lot to that, right? And so this is a whole set of guidance that's part of this Microsoft Cloud Adoption Framework. I'll click on that one. Again, put a link to it on the deck, but that one is aka.ms/caf. Again, not going to dive into this. The point of this is just showing you awareness, right? This isn't technology, but there's, starting right at the beginning, including what are your strategy, your motivations as a business at the highest level for doing the whole cloud thing. Why are you even bothering with Azure, right? It's not more than just somebody told me to do it, but there's like financial considerations, how you figure all those out. You're planning it. It's not just a matter of connecting something, plugging something together, lift and I mean, there's a lot to it. You need to plan and migrate this while keeping things upright. Ready, migrate, innovate, manage, secure, and finally govern, right? There's a lot of things that are beyond just technology. So it's project management, change management, people management. There's a lot to it. Purpose of showing you this is that we have this guidance, and there is an assumption that this guidance has been followed, right? That you've got some of this, that you've done this. A lot of customers have not. You can lift and shift, get a bunch of virtual machines from where they are on-prem, throw them in Azure pretty much exactly the same as they are on your data centers on-prem, and not follow any of this, and you'll be in Azure. But you will not have all the best practices that we'd recommend for governing it. How do you manage it? How do you monitor it? How do you secure it? How do you scale it? How do you manage the cost of all of those things? There's a ton of those things. And many customers, they'll start worrying about that once they've, okay, we've lifted and shifted it, we're done with it, we've got it all out. Okay, now what? What's next? And so this is actually what's next. Now, some customers, if they spend more time, if they're in less of a rush, will do this from the beginning. Other customers have evolved into this. And also I share that, this is only a few years old. I've helped build some of this. I've worked with customers before this guidance existed and has been built up with the help of customers. They've all, particularly the large enterprise customers. It's a journey, the same one. And has resulted in a lot of lessons learned, best practices. It's gone to have different names over the years. VDC was the first one, Virtual Data Center, you might remember that. This is the most current, most fully comprehensive evolution of guidance. Again, not technical, not particular Azure features. It talks to some of them, but not particular Azure features. Very high level. So, it has some principles that this guidance follows. Again, this is not technology. Subscription being a grouping of Azure resources, and who has access to those, how you govern that, right? How is that controlled? How is it managed? How are developers prevented from just spinning up whatever infrastructure they feel like and throwing their code on it and calling it production, which used to happen, still does at some companies, right? You need more governance than that, usually. Very long explanation as to why that might be the case. No, from long experience, that is something that is necessary. I have so many anecdotes. I'm going to resist. I could be here a long time, but anyway, know that these are things that honestly you'll need. This is the journey of success to migrating to the cloud. All of which pertains eventually to all kinds of workloads. This isn't just specific to AKS at this point. Right? We're going to get to AKS, but that one. But if it's just virtual machines, no containers at all, just VMs. This same guidance still applies. It matters, important. You'd follow that. Whatever the workload, custom applications, things, software you bought, software you built, whether you're a SaaS provider, IT shop, whatever it is, whatever your business, whatever your industry, and whatever your size. These same patterns apply. And so one of those concepts is called landing zones, which is a logical place that we describe. So effectively a virtual network in Azure, one virtual network that is peered, connected to a central hub. So hub and spoke. A landing zone is a spoke off of a wheel, imagine. So there are lots of landing zones against one hub, and one hub is regional. So here in South Central US, that's a region. You might have one hub in this region and then multiple spokes connected to it via VNets. Into that virtual network, then go workloads. That's infrastructure. It can be just virtual machines, and we're going to talk about AKS or whatever else you've got. Again, it's a pattern, irrespective. Proven lots and lots of reasons why you would need this. It has, this touches upon all the areas of reasons of why you would need this. Yeah, things that you need to be concerned about, things that you need to do, things that you need to have to be successful at deploying this. There's a lot, right? There is a lot. Honestly, there are workshops that can take days to explore all of this. My intent is not to teach you this aspect today. Just know that this is there, right? So as part of learning, if you really want to understand, and you should, the best proper ways to deploy infrastructure in Azure, irrespective of the workload, these are the patterns that we'd recommend. Here is an architecture diagram of a deployed hub and spoke with all the components and all of their glory. Subscriptions, various Azure services and components that form part of this deployment, including right at the bottom right here. I've actually called out, let's see if I can get up on the screen. Okay, I can't. A Kubernetes deployment. Landing zone Azure subscription. The best practice pattern is to have landing zones, one virtual VNet. It's in its own Azure subscription to facilitate governance and security. And you can see there's a lot of supporting resources and components, management, security components and pieces that should be in place irrespective at this point of the workload. Now, in this example, like I say, we've got AKS, could be a bunch of virtual machines, could be SAP, could be a bunch of databases, custom application, or dozens and dozens of applications that you lift and shifted. So it could be a ton of stuff. A lot of this pattern is, we have what I was showing you earlier, is created via those scripts that I was showing. But there is an expectation that you have this for your deploying your workload, including AKS, because this is the best practice. And that's why I'm calling it up. Again, I'm not going to go into depth. You can see there's a lot here, but hopefully the hub and spoke pattern is enough to give you an understanding of what we'd have here for a region. I can answer questions if you want, but otherwise I want to just keep on going.
Real quick, dumb question, please.
No such thing as a dumb question.
Just dumb people. When did Microsoft start using the term landing zone for their?
I think this is maybe this predates COVID, but not by much. 3 or 4 years, something like that. Yeah, it's not super new. It has evolved. Like I say, it was the virtual data center was the first incarnation of this, which was a bunch of scripts, a bunch of ARM templates that stood up, a hub and spoke. Hub and spoke being the traditional pattern that's been around for a long, long, long time. And now we've got a bunch of other things that go with that to enable basically a proper place of deployment of whatever it is you're putting in Azure. Virtual desktops, virtual machines, in our case, AKS. Okay, going to move on and talk briefly about Microsoft. So the purpose of that, again, was just trying to share and provide some links and guidance to a ton of other guidance that we would have, right? And it's a very broad scope, irrespective of the workload. A more narrow scope is the well-architected framework. This is, again, more guidance, a bit more specific this time, rather than previously that was an entire enterprise. That would be your entire company's strategy for how you operate Azure, all up, the whole thing, in multiple regions, irrespective of your size. The scope here is one application specifically, and that would be deployed, wherever it is, whichever regions, in ideally those landing zones you saw previously. We don't talk about the landing zones here necessarily. Instead, we have some guidance that speaks sort of a measuring stick, if you will, as to how, given any application architecture you pick, and let's say it's something you bought, like SAP. A lot of companies have SAP, and they want to run that in Azure. You'd measure the deployment quality, how well architected it is, against this set of framework here. And they might think, well, it's a VM, right? Just pick a big one, one that's big enough, throw in SAP on that, call it done. And of course, that's used to be what happened. Okay, then what, right? Well, measure the performance, and it's all kind of, it's been a long journey. It's been a long, long journey, right? Today, it's all broken out into these sets of guidance and best practices that actually assume at this point that you've chosen the infrastructure. So this doesn't help you choose out of all the Azure services that you have to pick from, and there's hundreds, as you all know, which ones to pick. It doesn't help you with that. It assumes, okay, it's SAP, or it's a custom application that runs on a bunch of virtual machines, or it runs on platform as a service, web apps functions, whatever it is, or Kubernetes in our case. We've picked that, and then we use the guidance here that is specific to each Azure service to measure, how well our deployment of that infrastructure, how well architected it is. And as you can see, all those things, well, yeah, we should obviously optimize for cost. Don't spend too much money, obviously. Operational excellence, that's how we operate the thing in production. Yeah, there's a bunch of, so we should monitor it, obviously we should monitor it. Makes performance should be performant. Sure, should be fast enough, absolutely, but no, don't want to waste money as per cost optimization. Yeah, reliable, of course, we don't want to fail, right? And finally, secure. Obviously, it has to be secure. So all these are obvious to everyone, but there's a lot more to each of these. And also, in particular, when you're choosing individual Azure services, there's features of those services that apply to each of these pillars that you optionally can choose to enable or not. And so going back to that command line that I was showing you earlier, includes none of the guidance for Azure, for AKS, that these pillars would determine. None of them at all. It's a set of defaults that actually, well, doesn't really do anything for you in terms of cost optimization, doesn't enable any monitoring at all. It doesn't enable auto scale, doesn't use availability zones, and there's a lot of security features that you could turn on that CLI does not, because there's options to pick from. And so well architected, so anything stood up with that CLI command is not well architected. It is the summary, right? It isn't, not at all. And that's the purpose of, yeah, it's not architected, it's a demo. It's a demo. And that's, again, one of the reasons for calling that out, right? Because that, a marketing team makes a nice and easy, nice, simple command line. Okay, fine, bang, well, there you go. You get what I was showing you on the screen, but it's not all of these things. And so what often happens, and this is the real killer, right, is that, okay, we stood this thing up. It worked. The developers say, yeah, it's fantastic. It's great. It worked. Their containers run like a dream. So, all right, fine. But our security team, they're usually the ones first, right? Sometimes it's the cost management team, but it's usually security first will come and say, hey, we've been testing your stuff, and it's, it exposed to the public internet, or, there's a whole bunch. Or our security teams have told us to lock it down a bit, do a bit more. What are our options here? We've been reading the documentation. How do we enable this stuff? Because going back to traditional virtual machines, right? You can just deploy stuff into a virtual machine, and then you can lock it down, right? You probably know that that's a secondary option. You configure it, shut stuff off, turn things down. With AKS and many Azure services, a lot of these choices, you actually need to make them up front. You can't change. You can change many of them, and more you're able to change more and more as time goes on. But some of the important ones, you can't actually change it once the cluster has been deployed. It defines and describes certain infrastructure that cannot be changed. You need a new cluster, create another one, and this time enable the features that make it well architected. And that's actually the purpose of one of the reasons that I put together this talk, because that's such a frequently asked question. So many customers have run into that. Some of them really hard. Cluster, as it turns out, is not well architected, and we've just found out, and we're struggling to make it well architected. Can you help us? No. You need a new one. So that's what led to this. All right. So just before we just go into some of the details for AKS specifically, that well architected framework applies to whatever your application is. Like I say, SAP, custom application that you wrote, it could be containerized or not, could be run in a VMs or not, whatever it's deployed to, whatever kind of application. That's the measuring stick you should use to measure each and every one of your applications. Not going to go into any more depth on that now. Set of guidance, AKA or MS. Sorry, another TLA, WAF, different one though. All right, and so we're going to talk about some of a bit more AKS specific now, because AKS is Azure Kubernetes Service. It's such a popular one. Just some of the specific preferences that relate for the WAF to it. And some of these are eye charts, because when talking with customers about some of these, some folks, like Ron, are very deep in networking. That's what they know and love, live bits and bytes, not so keen on maybe virtual machines, or not so much, or maybe the Kubernetes or security of those things, certainly not maybe about the workloads that's on top of it, right? And so there is a lot of depth to the networking discussion, but I'm going to try and stay a little bit above it and just give some pointers and summarize, honestly. But the networking is particularly deep with AKS, which is a little unusual for a lot of when applying this exact same guidance to other Azure services. The WAF, like I say, applies to all of them. There's a lot of complexity to Kubernetes, more so than many of the other so-called platform as a service. Because Kubernetes, AKS, it is a platform as a service, but it is a particularly complicated one of the most complicated. So at a high level, this talks about the Kubernetes I was describing earlier that you could download and install onto virtual machines if you wish. On the right there are lots of agent nodes, which is, again, just some software that's installed on virtual machines. You can install it yourself if you want. Coud proxy is the name of the software. And then the containers, the workloads, your applications run on those virtual machines. So shown diagrammatically here are two virtual machines, or bare metal machines, if you want. They can be. Kubernetes doesn't care. They can even be Raspberry Pis. I have a Raspberry Pi cluster. Yes, Josh.
We can talk about some of the very specific concepts.
A couple of them. We can touch upon some of them.
Well, like I studied what distinguishes.
Okay. We could. I'll try and hand wave, right? Because honestly, I think the details aren't actually necessarily that important to really know, because you do need to know if you're installing Kubernetes yourself, but AKS removes a lot of the need to care, frankly. So this is talking about Kubernetes as if you installed it on virtual machines. And so the point we're trying to show here is that there's a lot of bits that you might wonder about: kubelets, Coud proxies, agent nodes, Coud proxies, and pods. Pods is a group of containers. Well, that's a common piece of nomenclature that you probably will need to understand. So group of containers being typically an application deployment. You have lots of pods across nodes, node being a virtual machine, and then the internet or your local network calling against that. And then there is a control plane. Again, I said that Kubernetes, the problem it solves is you've got all these containers right here that form up your application, or lots of applications. That's the really common use case. It's not just one team's stuff. It's dozens of teams of stuff, all running on the same infrastructure because they can. That's one of the things that Kubernetes enables. Lots and lots, or versions of the same application. So you can have hundreds, dozens. You can have 1,000 nodes on an AKS cluster, 1,000 virtual machines. Each virtual machine can be one of the many sizes that it supports. So they can be colossal, and that can support a lot of containers. So a lot of horsepower underneath your custom applications here, if you want. Yes, Jeff.
You just said a lot of teams could be sharing
a single cluster, if you wish. Yep.
Well, I know, like, where we're at, a lot of teams will, I'm going to spin up my cluster. You're going to spin up your cluster. And then we're going to have to call in me and James on my team now, but and figure out how to get them to talk to each other and not talk to the internet and all these kind of things.
Right. Yeah, common pattern. Each application team gets their own deployment of infrastructure.
So we should talk to them at least about let's have this giant cluster that goes out with everyone.
You can. So that's sort of a multi-tenant cluster architecture. You can.
Okay.
So a couple of patterns really that you can have a central infrastructure team deploys a cluster the correct or best way, actually following all these best practices, which, as you can see, there's quite a lot of work there. That's sort of one extreme, the enterprise centralized cluster, and actually a lot of our best practices actually lean very much in that direction. The opposite direction of that is an individual application team, a pizza-sized team of developers, and maybe a DevOps person, figure out the CLI, get access, the IT team, give access to an Azure subscription, bill back is figured out, and that team stands up the infrastructure themselves, and they maybe get their own subscriptions. That happens a lot. So that chargeback happens, and there's no networking shared between those necessarily, right? But so they need to talk over the internet via certain ways. But what that gives is a great deal of autonomy. So the development teams out in the business, they will love that, and that's often the way it tends to start. Hey, we've got our MSDN subscriptions. We found this CLI right here. We know how to do stuff in containers. We ran the CLI in our MSDN subscriptions. We got a cluster. It was easy. It works great. Now can we do that in our business, in our corporate one? Okay, someone gives them permission to that Azure subscription. They stand one up. They get the same thing. It works great. They show everybody. They figure out the costs. Doesn't seem to be too bad. So, all right, yeah, let's do this thing. And that's a very delegated management approach, right? That's distributed operations, because that team then, they need to operate it, they need to secure it, they need to manage it, and configure it and update it, as well as do all the software. And that actually, as it turns out, is actually quite a lot of work if they do it properly. And they will learn that, and usually do, the hard way, right? When they want to know what's going on, oh, we need to enable Azure Monitor. There's a lot of stuff to that. Okay, what features there do we need to learn? Okay, do I really need to do this? Yes, we do. And then all of those things. So we tend to see that becomes a less favored approach. Maybe I don't really want, it seemed easy when I was just running the CLI to create this thing and just deploying to it. That was easy. It's less easy when I'm now actually operating the thing as the way I should, which is what we're going to talk about and started to talk about right now. So yeah, it can be a shared cluster, but what we often see too is a central team that has a pattern for the cluster everyone should use. So this team, hey, we want a cluster, we want an AKS cluster because we need one. Okay, it's created for them. There you go. Your business in the region that you want, named by the company, name it, follow this pattern using infrastructure as code, following all these best practices. Bang, there you go. And then another team can have their own one too, again, following the same script, deploy, bang, it's all best practices. And because they're following the landing zone pattern that I was showing earlier, they each get their own landing zone. And so the connectivity is done between those two landing zones, is handled and managed centrally. So the infrastructure can be, it's not actually enabled by default, but it can be allowed to happen because they're on connected VNets. Again, that's the reason for the landing zone pattern. Yes, so.
You can have a single cluster. Complexity to administer it, it's bigger and bigger. Like the more infrastructure you put into that one cluster, now you've got to deal with network security within the cluster.
Yeah.
Before that in one application might have multiple microservices running in there. This one application is all out to talk to itself, right? No real security implications. But when you start having multiple applications, you start adding more and more overhead in Kubernetes, before you know it, it's out of control. And that's why people, I think, have burned out on Kubernetes, because it becomes this monster.
It does.
Because it can. It's so easy for it to be.
And that honestly is actually the reality. It actually really is a monster. And that's one of the purposes of showing you all this slide. Without necessarily needing to understand all of this stuff, know that really it is kind of a monster. AKS, the next build on this slide, makes the monster a lot more manageable and easy to do. It breaks it up so all the complexity that was shown on that one part is now just hidden for you by an automated control plane. Yeah, okay. So the component on the left here is a set of management. It's if you're installing Kubernetes on virtual machines, it's called the master nodes, and there has to be some, and they're the ones that actually tell the worker nodes what to do. They're the ones that choose where to put the containers, and checks on the health of those containers, migrates them, auto scales them. There's a lot of those nodes. That's all they do, is manage the other nodes. And typically, in a virtual machine deployment, it's going to be at least 2 virtual machines for high availability. They will share the workload. You can have more than 2 if you want. And also, typically, that's all they will do, just manage the other nodes. AKS actually does all of that. It's just a service. Just does it. You don't even see it in your Azure subscription at all. It's gone. It's done. You don't even care. You do need to know it's there, however.
Background, probably
whatever your resource group was named, bunch of numbers, something else, resource question.
Gentleman has stood up to make a yes, and actually it is not that.
It looks like it might be a 10.
Yeah, so it's that. We're going to have other slides where we're going to dive into a little bit of that complexity. I hesitate to get too in the weeds with it. I'm trying to indicate some concepts and some dangers. So note that AKS hides a lot of complexity, so which is great. And the CLI spins up and up it comes. And this is exactly the trap I'm actually trying to warn everyone about, because this is what everyone falls in. Okay, we understand it's complex. AKS makes it look easy. Great. I'm in, I'm sold. I'll have one of those, right? Or two of those, or however many. And then, but it is the complexity after that that is what traps everybody. And that's what I'm going to talk about now, because like I say, that CLI doesn't have any of the best practices in. All right, I'm trying to get on to the next. Oh yeah, thank you. Okay, so this is benefits of this automation. What makes it easy? Why it's so great? Because it is. It is great. Not trying to knock how great it is, but just it's about knowing. It's about knowing there's more to it than how convenient and easy it is. So it does a bunch of stuff for you. This part now, we don't even charge you for this part. That would be 2 virtual machines, although there's a paid tier with an SLA that does cost. You only pay for the virtual machines. It's all the Linux virtual machines. You only pay for those and nothing else. So it's, for most customers, pretty low cost too. Pretty affordable, really. There's auto scale that you can choose to enable that the CLI I showed you does not turn on. But you can choose and should, right? Choose to have that in order to minimize your costs, being one of many examples of features that it has. Okay, this is a lot more weedy as to the components of how you should deploy AKS. Now, this is often, because of the complexity that you can see here, deployed by a central team, more so. So this is not a development team, an individual application team. We're not doing all of this. But this is how you should do it. So let's walk through what we should have here. Okay, on the left of the slide, there is some connectivity to on-prem. ExpressRoute is the usual, also site-to-site VPN. And this is also in one region, one Azure region. You would have the same pattern in multiple regions if you want. So that's how all the development teams and everyone should connect to this thing, not via the public internet. They should site-to-site VPN, ExpressRoute, whichever. That connectivity comes into a hub that is managed by the networking team, the enterprise networking folks. Again, developers don't care, but that's done for you and should be how it's done. This is the hub drawn in the middle right here. In this example, we put in Azure Bastion, which if you've got ExpressRoute, it actually will probably be unnecessary, but it's an optional feature because you could connect to all of this infrastructure from VMs if you like. You wouldn't have to use Azure Bastion. So consider Bastion in this pattern optional. It's an optional component. And then you have other spokes with other workloads. One might be SAP, one might be application XYZ, might be sometimes a business units applications, whatever you've got in multiple spokes, all connected via VNets to this one. And AKS spoke here, called a spoke, also a landing zone. So the logical name is a landing zone. There's all this component on the right. The pieces that we have, and this is Azure infrastructure at this point. I'm trying to get my cursor pointer up. On it. Okay, I'll just walk through it. I can't get my. Oh, there it is. There it is. So over here, a jump box might be necessary in order to access some. So, for example, set the management up of your AKS cluster. This again is perhaps optional if you can see everything from on-prem right here. So if your desktop, your laptops are connected via this ExpressRoute, then again, you might not need jump box necessarily, but you probably will need build agents. So if you're using Azure DevOps, then you would need build agents that are able to talk privately via this VNet to this cluster, because there's no other way to talk to them when you've configured it the way we've shown in the diagram right here. Other components will be an internal load balancer. This is created for you when you deploy your AKS cluster, and this is how traffic gets to your cluster. So nothing talks directly to the virtual machines that run those containers that we were showing. Everything goes via internal traffic, that load balancer right there, and it load balances the traffic across those virtual machines, and it does that for you. So it's not some complexity that you have to manage yourself. That's a feature of Kubernetes. You effectively, if you're doing, typing the name of a website, whatever, you actually would resolve to that endpoint on this load balancer right here. Lost my pointer again. Goodness. Cannot be this hard. Go. I think it's just the way the screen is oh, there it is. And then, so that was the build agents right there. And then this is a subnet all by itself where your AKS is deployed. So this is a virtual network and a subnet on the same virtual network where these are the nodes, the VMs of the AKS cluster are deployed to this. It's called a node pool. Each node pool is a same size virtual machine that can auto scale up to 1,000 nodes per node pool, or up to 100 node pools per cluster, for a total of 100 nodes per cluster, irrespective of how many node pools you have. So you could have 10 node pools if you have the most number of node pools. And each of those can be independently auto-scaling and different Azure infrastructure virtual machine sizes to run all your containers and your workloads. So you can see how, given the amount of infrastructure that could be as part of this, can be gigantic. The minimum effectively is one virtual machine on one node pool. That's the smallest it can be, but that would be for dev. I mean, wouldn't hold a lot of workload. You'd need practically at least 3 VMs running on here. And then you have an application gateway, another piece of Azure infrastructure for your internet-facing traffic, if you have any. And this is the only way in which traffic can and should come to your AKS cluster if you have applications that need to come in from the public internet. This, again, optional. You might not need this at all. Again, not created by default. That CLI I showed you earlier will create this load balancer and have it internet facing, allow it to be internet facing if you let it. So part of our best practices is not to allow this to be internet facing. Keep it internal only. So it's going to pull the 10 dot or whatever from this VNet, and this is how you access it internally. And only if you need external traffic, use this application gateway. Many of you may be familiar with Application Gateway. If not, it is a separate piece of Azure infrastructure like the load balancer, got nothing to do with AKS at all. Separate piece of automated, what's called a layer 7 load balancer, so designed for web traffic, HTTP, HTTPS. It has integration with AKS, specifically in that AKS has a piece of software installed upon it, or can, optionally. Again, that CLI command I showed earlier does not install this piece of software that I'm describing. It's an optional extension that you can and should add to your AKS cluster if you need internet-facing traffic to hit workloads on your cluster, that has the ability to control via the Azure control plane, via automation magic, this piece of Azure infrastructure right here. So it's able to add load balancing, SSL certificates, configure the ports, configure incoming traffic on this appliance, so that, again, you don't have to. Otherwise, yeah, go ahead, Josh.
Are you saying that there's a sort of like a sub-resource deployed with AKS?
Yep.
Like a blade internal to AKS that manages a load balancer if you turn on certain options?
It's not a blade. So AKS, basically, it's those node pools. A node pool is auto-scaling virtual machines with the same Linux or Windows image on it, upon which all that Kubernetes components, kubelets and stuff we don't really care about, that makes Kubernetes work installed, as well as your containers doing the work, and optionally extensions. And that's what the piece of software that is able to control this application gateway is installed as. Extensions, there's a variety of extensions. We provide some, we can talk about, there's a bunch of those. Like agents, consider it as an agent. Like you might have an agent, an agent running on a PC. It's like that.
It's like an extended feature.
Yep.
Separate Azure resource similar to like application.
So this is a separate piece of resource. It is an application gateway, this component right here. It's different. It's separate from your AKS, but there is an extension, some software installed on your cluster itself as a workload next to your applications that has the ability to control this external piece of Azure infrastructure.
Runtime or
All, yeah,
configuration and design?
at runtime and at deployment time. And so what that allows, so traditionally, let's say we didn't have this. Let's say we didn't have this component and we wanted internet-facing, so it's a website. Developers have created a website and it's our corporate website, adamsawesomewebsite.com. I deploy it to my Kubernetes cluster in the usual way in containers, and all is right with the world. And I'd have it deployed across multiple virtual machines for high availability, and that's great. I need some way of ingressing traffic to that thing from the public internet. And so the best way, there are multiple ways, the best way is to use that application gateway. And I could install that, go into the portal, install application gateway, deploy that thing, give it it's going to have a public IP to which I can then assign the domain name of my website. And then in order to have, it needs to load balance the traffic that comes into application gateway to my container, my application behind it, if you like, the website. Now, this traditionally might be a virtual machine. It's going to be containers on my AKS cluster right here. And I'd have to configure the application gateway to what ports, what the IP addresses of the virtual machines, what SSL certificate to use, and do all of that. And if I was just using virtual machines, no AKS, that is exactly how I'd have to do it. One application gateway, two virtual machines, install IIS, put my software on it, and then configure application gateway to load balance to the two IIS instances, and it would load balance the traffic. I would hit the front end, traffic would come through, bang, one highly available website. And you can do the same thing with AKS, but the difference, of course, is that you've got multiple applications potentially running on the same cluster if it's shared, or maybe it's your own cluster, right? And you might have multiple websites. Some of them might be APIs, some more websites. There's a dev environment, prod environment. There's all kinds of stuff you've got on there, not just websites, but yeah, APIs again, some of which, but maybe not all, need to be internet facing. And then to configure that load balancing on this appliance would then be a lot of work. It still has to be done. It's still necessary. The application gateway will by default load balance nothing unless you tell it what to. AKS will actually do all of the work of configuring all that routing and load balancing work for you as part of this automation software that I described.
And so, because somewhere in the AKS cluster, there's been something descriptive that says, look, I'm looking for traffic of this type, whatever that is, domain name, or etc.
Yeah.
Bring it to me. And then
That's right.
AKS, you figure out where I am and how to grab it.
Essentially, yeah, that's right. So that's the last part. The last part is, well, how did we get it to, how do we describe that? Yeah, there's some JSON, some configuration that is a format defined actually by Kubernetes. It's not an AKS specific thing. It's actually generic Kubernetes that sort of it's all in JSON that describes that essentially. And that text file, that JSON, is given to the Kubernetes cluster, like you kind of indicated, and Kubernetes is told, figure that out, and it does. It will configure the application gateway, deploy the workloads, figure out the load balancing, and as it scales in and out, it will make adjustments as needed. And then if you take that workload off, delete that, I'm done with it, it will then take off the routes, take off the SSL certificates, remove the ports, whatever it is that needs to happen. It will add it or remove it or scale it in real time as it does. Question one.
Yes, so what's the benefits of using
the benefits is, Azure Front Door does indeed do pretty much the same thing. It's a load balancer. A big difference is that Azure Front Door will scale across regions. This is regional, so it's one region. But the biggest difference is that you have the ability here to have AKS do the work of configuring all the routes for you. With Azure Front Door, you're going to have to go and tell it what the backends all are. Yeah. And application gateway still needs to know what the back end is, which in this case is it's nodes, it's VMs running on that AKS subnet, but AKS will take care of that for you.
So in that respect, for those who don't want to know, or not interested, or don't have time, or whatever, or don't want to manage,
Just don't care.
AKS is gonna take care of it for you.
It's going to take care of, yeah, so it's a security appliance, which a lot of security people want. Yeah, I want a security appliance that's internet facing, like Azure Front Door, not actually like a load balancer to one to the left, not a security appliance. It is secured by default, you go to the standard one, but it's not a security appliance. This is a security appliance, so it meets the needs of the security folks, but it's managed and automated
So
for you.
built for developer geniuses who hate dealing with infrastructure and everything like that.
Yeah, so it makes the life easier for developers, that's true, but there's still a lot of complexity even as a developer. But that actually is a nice segue because as Josh's question, so AKS needs to know to some extent, it needs to know what to tell the application gateway to do, right? It needs to know what the front end is, what the SSL certificates are. And so that definition is actually part usually of the code. So it's actually configured and deployed. So the developers need to have an understanding of this infrastructure in order to know how to craft these deployments. It's just JSON. It's not complicated especially, but the developers need to know so that when they take their application and deploy it to this cluster, which is again more descriptive code, that AKS will then configure the application gateway with the right SSL certificates, with the right ports, so that their application is exposed to the internet, because no one's going to do it for them. It's fully automated. And if they don't do it, then what happens is it will get deployed to AKS, and that's fine. It will do that, but it's not going to be. You can't call it. You might be able to call it from the load balancer up there on the left. That's reasonably straightforward, and usually the default. And actually, what you want if it's only internal traffic, right? You would want that. But again, there's still some knowledge of the fact that you have what even is a load balancer. What even is that? When you're going to use it to deploy your application behind that thing, you need to have some knowledge of what it is. Now, more mature over time, we tend to see, again, as part of the, separate from technology at this point, right? Just the way in which organizations evolve. Now, I talked about some of the natural silos, networking, security, developers, natural silos in organizations. Another one of those, and those silos need to come down a little bit, as you can see, because we're crossing quite a lot of silos here to some extent. It's important that developers know about the infrastructure where their code is going to be deployed in order to do so successfully, because it has some ramifications about how they deploy it. But also sometimes that can be broken out as part of the DevOps lifecycle. So some of the management and operation of what we were just talking about can be delegated to DevOps teams that aren't shown on this diagram. So developers can just own the code. We have another role as part of DevOps called the banking. So there's an app engineer, application operator. Application operator is the name of a role whose job it is to understand what the code that the developers create is and what it does, essentially, the software architecture and this infrastructure, and actually just create the descriptive JSON that joins those two together in AKS. That's an application operator role. And when you have a lot of teams all using the same clusters, then that person's job is to join the code and the infrastructure together. So there's three roles: developer, application operator, and Kubernetes administrator, which is the person who knows how the Kubernetes stuff works, because you still need to know a little bit about it. I'll have a little bit more about that. So part of the maturity, again, you can create the CLI without having done any of that, right? But those are the things, as you use this more, particularly as you pack more and more teams onto it, further down the maturity level, those are the kinds of skills or roles that we tend to see evolving as a result. Does that make some sense? Yeah, because good segue, Jess. So yeah, like I say, that becomes eventually someone's job to actually do that. Maybe a part-time or a role.
Too off topic. Would the unit replication here be for a dev environment?
Okay. Yeah, okay, great question. So the spoke would be the same. There's only one.
The whole spoke.
The entire spoke on the left, there's only one of those, no matter how many spokes. Oh, wait, did I say spoke? Excuse me. I meant to say hub. The word I meant to use was hub. Referring to this right here, only one hub, multiple spokes. Now you may choose to have, and what is commonly seen as a dev spoke. So for a given application, this is our dev spoke. So it might have slightly different governance applied to it. Maybe it's a little less restrictive, or maybe more so, you know, depending. But the components within it, to answer your question, other than the, you know, it being another spoke potentially, but not necessarily, would be exactly the same. You'd have all the exact same components for a dev environment right there. The only difference would be the name, to answer your question. So one difference you might want to have is, you know, you don't want to spend so much in dev, right? There's not such a need. Auto scaling can help with that, of course, scale it right in. You might want smaller virtual machines. Maybe pick a different family, a cheaper family. There's B series, for example, virtual machines, burstable, pretty cheap, but good for not being used a lot and occasional spikes. No good in production.
But we're trying to replicate effectively some level of like spoke or more, not within the spoke.
Yeah.
You're going to share as much as possible between them.
Yeah.
Where it's not meaningful, and then maybe just duplicate the cluster.
You can absolutely.
Oh, okay.
Yeah, you could.
Two separate hubs, two separate spokes, two separate, you know, AKS clusters, because they want to operate in two different regions.
Yeah.
Theoretically, we can do that as well. Which doesn't, it's just something that I saw do.
Just it's like just the cleanest level of.
It is nice and clean. Yeah. Yeah. But not necessarily. You can have, for example, a business unit spoke, business unit A, and they might choose to simply have it at a cluster level, right? So there's going to be a dev cluster and a prod cluster in the same spoke, just named differently on different, the same view.
Each spoke can represent a business unit, represent an as a service. They want to do their own CAS as a service. So they got an enterprise level business unit that's running the entire containers in that spoke, to all the way down to I have a business unit that has 5 different clusters because they want to run 5 different spokes for various different workloads. They all want to keep attention. So it just depends on what granular level they go down to at spoke level, and ultimately what they want to define that unit as. So we don't restrict you, it's just.
Yeah. We also don't necessarily have like guidance as to best practices necessarily, but yeah, to your point, I think what, you know, the summary is, yeah, all of that for dev too, I think, because that's another mistake, right? Or what don't we need? What's only for production? We'll just, you know, we want to cheap out, make it simpler. Why do we have to have all this stuff? Yeah, you need all that stuff even for dev. Short answer, yeah. Different spoke, maybe, same if you wish, but you need all that. Question, Josh. Resource, so the logical sort of onion circles are the highest level, a management group. Within a management group are Azure subscriptions. Within subscriptions are resource groups, and within resource groups are the individual resources. You would have multiple resource groups within a subscription, and typically a subscription is a landing zone. So that's a spoke right there is typically a subscription all by itself, containing multiple resource groups. So that's a resource group, that's a resource group, APS is in a resource group, these might be the same resource group. So, yeah.
Serves no purpose when it comes to trees as such. So you don't have to have a VNet sitting in each resource group.
Yeah, there's no network boundary or things that prevent traffic from going between them. Yeah, I'm not sure we do have a great analogy. It's Yeah. It's a label. It's like saying this half of the room and that half of the room. There's nothing to prevent you. Yeah. And that,
Management construct around infrastructure.
That's
That's what you're saying.
But attacking work the same way I was saying, this tag, these people have access to it, it's the same analogous to that, to say if I put these. So it's just we use the construct.
yeah, it's a border, a logical border that you can secure. All right, any other questions for you? I mean, this is probably the most complicated diagram and really the details of a lot of AKS stuff in here, but this is how you should deploy it. And the CLI deploys absolutely none of this at all. Not a scrap. It deploys this part and it deploys a load balancer, and that's it. And doesn't prevent you from doing all the things that this does, like, for example, requiring internet only through the application gateway. That's how you should do it. That CLI command does not prevent that at all. So problems arise, right? That's one of the key lessons I'm trying to convey here. Trying to convey, the where people have stubbed their toes. It seems so easy, but I'm trying to not scare anyone with like how hideously complicated it is, but just there's some understanding of a lot of things that we recommend that you turn on that make it more complicated than it at first appears. Oh, okay. Yep, the AKS master. So in an earlier slide, I had a diagram of the nodes where your applications get deployed, and then there are what's called master nodes, which is a feature of Kubernetes that basically it's the control plane. It's what tells everything what to do, and that's a managed service as part of AKS. Yeah, it's yeah, which is it's this part on the left right here. It's this part, the managed control plane, and then there were the VMs where your containers go. It's that part, and yeah, I'm trying not to go into too much detail here. Oh, my slide's still building. But the purpose of it being on this diagram is that it's shown connected via a service called Private Link, which again the CLI does not enable by default. Now it is an option if you go through the portal actually, and if you enable it as you show it in the diagram, then that API, that component is not internet facing, which is how we recommend you have it, which means that you can only control deployments to your AKS cluster from within this VNet, locks it right down. If you use the CLI, then that control plane is internet facing, which is a.
So if that's the AKS master, wouldn't your arrow be pointing the other direction though? Because isn't it controlling your?
The flow of data is, but not the directionality of access.
Yeah, the diagram here is meant to be indicating control plane requests. So deploy this workload, scale this. It's yeah. There's some room for improvement on this diagram.
This is the story.
It tries to convey kind of a lot in one diagram.
Oh,
yeah.
I would be stealing on.
Oh, you can have it. Absolutely. Yeah, you can have it. Yeah. We have diagrams like this on the docs. This one was created for this deck, but you're welcome to it. I mean, so, all right. Yeah.
It's not dedicated for outbounds.
That's right. Yeah. So it is a one-way call to that node to tell it to do something. Deploy something, undeploy something. It's management traffic, if you will. And shown here, it can only be done privately from your private network. By default, it's internet facing. It has it's an internet URL. It even shows you on the portal what the URL is, and public IP. Yep, can be called from anywhere on the internet. And so that means that commands to tell your cluster to deploy things can be issued from anywhere in the internet. It is of course secured, and there's options and way in which you can secure it. We recommend you secure it using Azure AD, which I don't think is shown on this diagram. This is more networking. not enabled by default. Where are we looking?
It says ACR.
Oh, that's not, that's an assumption.
Oh,
That's Azure Container Registry.
yes.
We just want to make sure the meter is spinning.
Well, yeah. So of this diagram, the most expensive part is the firewall, and you'd only have one of those per region, right? That's the most expensive component. Bastion can add up, actually. That thing scales out. Express route can be quite a lot if you have a decent sized pipe, right? But you only have one of those for lots and lots of landing zones. The expensive part of the AKS cluster is probably the application gateway. But you should enable auto scale on that thing, and it can auto scale all the way down to 0. So you're actually running costs of this. If you enable all auto scaling features down to 0, it can be pretty low. It's not a lot.
That's for the jump boxes, I believe.
Yes, yeah, that's so VM scale sets is a automated IaaS component. If you're using jump boxes, which as it sounds, you connect to it in order to manage your AKS cluster, then that's an infrastructure choice you can make. That component is optional.
Some people run it.
Yeah, that's right.
But the way you're using peering.
You would always use pairing because this is a hub and the spoke, and they're always paired. So those networks have direct connectivity, and all the network traffic is controlled by user-defined routes to always go through this firewall outbound and traffic incoming through. Yeah. So you can manage and secure all that network traffic in both directions. Question from Maxwell.
Yes.
Yep.
If your containers are public registries, they're good practice
for those.
Yeah.
Yeah, there is. Pull them out of the public registry and put them in the private. Yeah. Yeah, get them out of there. Yeah, that's right. So actually that Flux is part of GitOps, which is, okay, that's a further discussion. Haven't got there yet, but give us a minute. All right, so this was a lot of infrastructure. Question from? Yeah, we're going to talk about the Azure Container Registry. We have some recommendations for how best to use that. That too should use private link as well. Yeah.
For the same application, we want to have it active.
Okay.
Is it 2 different spokes?
Okay.
One in the west and one.
So everything we're going to talk about, that's a reliability question a little bit, which we have a slide on. All the components in here in this one spoke should be across availability zones. And that's features, again, the CLI does not enable for you. All of these Azure services support zones. Some of them you have to specifically tell it to use those. Application Gateway being one example, the Azure Container Registry being another, and actually the node pools being a third. Now, by using zones, then the VMs in your AKS cluster and these other components where your containers are deployed are in different physical buildings, different power, different ping, different pipe, all within the same region. So you have high availability if you enable that feature, which the CLI does not, when you deploy your node pools. If you want active, which is a more of a disaster recovery question, so that was a high availability, which I'll come to, then you could have it in another spoke, but that would be in the same region at that point. So there's little point because you have in region, or you should, right? You should have in region high availability within this spoke for that region. What you need for disaster recovery is this deployment in another region.
Well, I wanted more as an active, and don't use the application, use the front door.
So
in and everything else, so I can go
Yeah.
in.
But then
Send
you
my
have-
customers.
Yeah.
You have multiple hubs and you have multiple spokes with the.
So it's a complete replica?
Yep. That's exactly right. Yep. You'd have this whole pattern bang stamped out in another region with your front door. You'd have all of this. This is internet facing right here. You'd have your front door endpoints, this one and the one in another region. Everything here would be identical.
When
Then
you start using private link service, Azure Front Door, so that Azure Front Door being a local service, you can talk to private endpoints. and that.
well, not in this pattern, however, because this is
Not this-
not in this pattern. Yeah, this pattern you'd point it against a public-facing application gateway. This application gateway has to have a public IP. So if you're gonna use that, then that's how you do it and have it in 2 regions. Now the separate problem is how do you replicate the data of your application between those 2 regions? AKS doesn't have a story on that. That's actually application specific. The answer to that question is basically choose a data store that you can replicate between regions easily. Cosmos DB, SQL database, etc. Pick something. Do not store it all on the disk of the cluster. Okay, moving on. So actually, this slide actually talks to the application gateway. This just dives into, we already sort of covered this, if you will. The software that I described being deployed to the cluster is called Application Gateway Ingress Controller. That's the software, and Application Gateway is the infrastructure. I think we've already talked about this, so I'll move on. Something else that you need to know that you can choose, that the CLI does not deploy, that we recommend that you have, is network policy between the pods of your cluster. What that means is you're probably, many of you are maybe familiar with NSGs that you deploy to VNets in Azure. So that blocks traffic by default and controls it between the subnets, right? You can apply them to virtual machines. This is actually deployed in the cluster itself, which means that via this capability, applications that share, because remember they share the cluster potentially, cannot talk to one another. That's desirable. That's a security best practice. You'd want to block that. By default, it's not. So that means that application A can speak to application B on any port. You should say, well, it only needs to speak via HTTPS, for example, and configure network policy on the cluster to enforce that. That's some additional complexity. It's not done by NSGs at this point, because NSGs are outside of your AKS cluster. This is a software concept within the cluster. Know that this is a capability that Kubernetes provides, not AKS. This is a Kubernetes facility, and we provide 2 options out of the box for you to pick from. We're just going to have an opinion and suggest you pick Calico because it is more mature. There's one we made, and there's the Calico one. Calico's a third-party vendor, software vendor. It's all open source. Pick that one and apply policy. So deploy it, first of all. Number 1, deploy this Azure policy to your cluster. It's not there by default. That enables the ability for your cluster to constrain traffic between the pods. Number 2, require that the application definitions, when they're deployed, your software actually uses this thing and determines what the ports it should talk to every other pod on, if any. Might be none at all, in which case that's how it should be documented. And then Calico will ensure that that is the case, which is a security best practice. Did that make sense at a high level? A pod is a Kubernetes concept. It means a group of containers. Yeah, it can be just one container, but it's one or more related containers. And that's an application is defined as a pod. A pod is always deployed to one virtual machine, so one node. A pod never goes across nodes. It's deployed to one. You can fit multiple pods onto one virtual machine if there's enough capacity, CPU, memory, such like, and Kubernetes will help you determine that. If you don't have enough capacity on, not enough virtual machines, autoscale is not defined, then the deployment will fail because there's no room. Or it will enable autoscaling and it will find capacity for you. That's part of the magic, the automation that Kubernetes does. Yes, you do, and you have to choose the size of the machine, and you also can't change it for any given node pool. You pick the size, the family, the number of cores, and you get at least one, and we recommend 3 for high availability, 3 availability zones, up to 1,000. Okay, all right, enough on network policies. Know that it's not enabled by default, and the best practice is enable it, pick Calico, and use it for Azure policy. All right, we already talked, you already had some questions about reliability. Well, just one slide on this is, again, best practices, right? Things that aren't enabled by default. This is another view of the same picture. This is just from our documentation, in fact. You can recognize some of the same components. So we've got Azure Firewall. You saw that in the hub in the previous diagrams, which is what's represented here. We have a hub, bespoke. Optionally, and you should configure these components to use availability zones. I previously explained what availability zones, different physical buildings within the same region, up to 3. And you can choose and should have the infrastructure use all 3. So Azure Firewall supports it. In fact, all these services support it, but the ones I've put stars on here, they don't use it by default. You actually have to configure it to do so. And in some cases, it's not even enabled in the portal. You have to actually put it in the infrastructure as code, which you should be using, because remember, we don't use the portal to create infrastructure. That's one of the reasons we don't use the portal to create infrastructure, because it doesn't have, or at least there is a lag. It usually eventually has all the features, right? But there is a lag between what its service is available now, the features it has, and them getting lit up in the portal so you can use it. Just pretty much never. Pretty much never. But the infrastructure as code gets them very, very soon, really quickly. Yeah, all the preview stuff is there now. Yep. Yep. Don't use the portal. Okay, to create infrastructure. All right, so Azure Firewall, enable AZs. Application Gateway, enable AZs. We talked about the load balancer supports it by default. There's nothing that you need to choose there except for the SKU. You have a choice of 2 with Azure, the basic SKU and the standard SKU. Both work just fine. The key difference is that basic is free and does not support availability zones. Standard does. That's the one that you want. There's a price for standard load balancer too. Application Gateway also supports availability zones, not enabled by default. I think that one also is not lit up in the portal still. So application, your infrastructure as code should define that, as well as you need a zonal public IP for it as well, 2 components, and then your application gateways delivered in zones in regions that supports it, like South Central US, where we are here. Similarly, the node pools for your Kubernetes cluster should use those too. Incidentally, using AZs typically doesn't add any cost. Some SKUs, if you change the SKU, like storage account, for example, if you pick a SKU that is zone enabled, there is a price cost for that. These services, there's no change in the price for enabling AZs, so not a reason not to do it. And also, another frequently asked question, there's no cost for traffic going across those AZs. In the physical different buildings, if you've got applications running on different nodes and talking to one another, that traffic is literally going between 2 different buildings within the same region. No cost for that, no cost for traffic moving around on the same VNet. So they're still on the same VNet. All right, so that's high availability on the Azure Container Registry. Also supports it. You need to turn it on when you deploy it in order to use it, and pick the premium SKU. Key Vault automatically uses AZ, so you don't get an option with that. It just does it anyway, so there's nothing to configure, fortunately, and that's all. Any questions on that? Again, AZ doesn't create that, and there's some supporting services we recommend you use, as you can see, but aren't there by default. Okay, moving on. All right, so this is just some summary best practices, some of which we've actually covered, right? These are just some bullet points, and we're getting towards the end of the content right now. Just some summary, some quick hits, and you can ask questions if you like. So, and this actually is a summary of for almost every Azure service in the documentation. There's what's called a security baseline, and it is a monster of recommendations, just a huge, big, long page. Varies by service on the amount of complexity. With AKS, it is a really, really long document. There's a lot of recommendations and practices. I sort of boiled them down on these few slides because honestly, it's very, very onerous, frankly. Okay, so we talked about a recommendation that's made in the security baseline. Generally speaking, best practice is use a hub and spoke technology. We covered that earlier. We talked about that diagram. So just a repeat of what we said earlier. You should put it in a hub and spoke, but not, there's more to it than just a hub and spoke. VDC was a hub and spoke. There's governance, there's Azure policies. There's a lot more than just the VNets, right? There's a lot more to it than that. So some of the benefits of that, we recommend, generally speaking, use a web application firewall. This is a networking concept. The application gateway supports that. So does the Azure front door that you guys were talking about earlier. Recommend using that in front of your web-facing applications. Kubernetes doesn't know, doesn't care about web application firewalls, couldn't care less. There's no clue. If you use one of those, it doesn't care, whatever, doesn't care. But we recommend, generally speaking, that you should use that. And then, okay, so a bit more of a networking, a common toe stubber, right, is because Kubernetes, we recommend that you use a hub and spoke. That typically means that hub and spoke is an extension of your on-prem network. So those IPs then are addressable from on-prem. And so many customers, particularly enterprise customers, have trouble managing their IP address space because they might not have planned for enough IPs to be available to these hub and spokes. Planning is very important with Kubernetes because it can use thousands of IP addresses very, very easily, which comes as an absolute horrible shock to the networking folks who talk to the application teams who they're more used to VMs, right? How many VMs do you want? 10. Okay, fine. 10 IP addresses. Well, yeah, fine. Okay, yeah, we got that spare. Not a problem. Kubernetes, how much infrastructure are you going to use? I have no idea. I mean, it's going to scale in out. We're going to use as much as we need, but not any more than that. And there is actually some additional complexity because Kubernetes has the ability for each of those pods I was describing, in addition to one IP address per virtual machine, a 10 dot, in the usual way that you'd expect, each pod on top of that virtual machine can also pull an IP address from the VNet. So that means you can have up to 250 or so pods per virtual machine if it's a big enough virtual machine and the pods are small enough. Each of those would pull an IP address from that VNet for that one virtual machine. They're just yanked. There's no NIC, showing you what those are. They're just consumed from that VNet, which is a horrible shock to networking people who this is not how networking works. It's a VM, there's a network interface card, pulls an IP address, and that's it, which is still the case, and all this pod concept. So that means that that's why an AKS cluster, even with 10 or 15 nodes, can pull 1,000 IP addresses quite easily. Not only that, but you also have to plan to some extent for scaling of those nodes, right? Because as they scale, each node will require a new IP address in the usual way. Nothing unusual about that. But also, unlike virtual machines, you don't get to change the size. You can't scale up your virtual machine, pack more into it, like you might a virtual machine. Okay, this VM's too small. We don't want to waste IP addresses. Shut it down, make it gigantic, boot it up, and it's huge, still uses one IP address. That's a normal virtual machine pattern. AKS does not work like that. You pick the VM size that you want, and you're stuck with it for that entire node pool. And it'll go out to 1,000 nodes if you let it, but it's all the same virtual machine size. So by scaling out and not up, it's consuming more IP addresses, and you can't scale it up. In order to change that, you have to create another node pool of the size that you want, migrate your workloads, delete the first one. You can do that, a little bit of work, not too bad, no downtime. But again, for networking folks who this is weird, right? That's not how VMs normally work. Sorry, say again, Mark?
So even though you might migrate to a larger VM size, you're still going to consume the same number of IP addresses, you're still moving over the same number of pods.
That's right.
So IP address number doesn't change.
Yes. But what happens a lot, right, is that folks will start off with a small VM size. They don't want to spend too much money. We'll have a little one, 2 cores, 4 gig of memory, plenty. We'll just have a few of those. How many do you want? Well, many as we need. And they find that their containers fill those up pretty quickly, enable auto scaling. Loads of VMs start spinning up because AKS will just do it as it needs to. The development team are testing their stuff. Everything's working fantastically. IP is getting consumed. and running out. And when they're an extension of on-prem, that can be a problem. So IP address planning is really important, not just for the application, but also for other resources that are connected by private link to that VNet. So you're connecting your Azure Container Registry, you're connecting your storage accounts, your Cosmos. Each of those pull an IP address in the usual way from the VNet. And finally, when you upgrade the cluster, then you're going to have additional nodes with new versions of Kubernetes underneath it or new images underneath it that Kubernetes will spread out the containers onto those new nodes and then shut down the old nodes as part of the upgrade process, right? It does a lot of that for you. It's automated, but know that it is temporarily going to add more nodes in order to do its internal upgrade stuff. Again, can be a surprise to networking folks who aren't very keen, particularly when it's an extension on-prem, to give out loads and loads of IP addresses that they can't see being used. 1,000 IP addresses for one cluster? There's 3 nodes? Why do you need so many IP addresses? And they will need those many IP addresses. And there is another networking choice called Kubernetes. Oh, so I talked about the IP address here. You have another choice. Let's see. Let me talk about that. I think I actually deleted the slide on it. I did the slide because it got kind of in the weeds. But know that you have 2 choices of networking infrastructure. One of them is the one I was describing. It's an IP address per node, and then each pod will pull an IP address, and that one uses the most IP addresses. There is another virtual network choice that's native to Kubernetes. It's actual virtual network within a virtual network. So Kubernetes maintains its own network within the cluster, which is great because that means that only the pods then don't consume an IP address. You can have lots of pods and they get an IP address instead from this internal virtual network that's inside the cluster. So it seems very appealing to a lot of folks because then it's more familiar in that each node, each VM effectively pulls one IP address in the usual way, and then everything is fine. It's easier to plan and then pack loads of pods onto that thing, and life is easier. What gets more complicated is ingressing traffic to that thing from the application gateway because it's a VNet within a VNet. So it's actually, the complexity is something we recommend avoiding, usually speaking. But it appeals to people, networking folks who are short on IP addresses. But yeah. So anyway, beware of complexities, and we don't recommend Kubernetes. We recommend CNI. Or Azure Container Networking Interface. All right, couple of compute recommendations. So I mentioned that it is Kubernetes, the open source deployment, not a Microsoft flavor of it, and it gets changed all the time by the open source community, not by us, not by Microsoft, but by the open source community, changes it, and new versions come out, and you have to keep them updated. You, the customer, the owner of this cluster, not done for you. You have to maintain and keep those updated and tell AKS when to go and get the latest versions of Kubernetes. And that's a Kubernetes operator job that a lot of developers don't realize. The CNI, the command line right there, gave no hint, right, that you were going to be in charge of updating Kubernetes versions. No hint whatsoever. It was a secret. Yeah, well, welcome to the world of Kubernetes. Yeah, that's something you're going to have to do. And in particular, you'll get nasty emails if you just ask around. I mean, it's fine. You'll get emails if that version drops 2 versions behind, because you'll then won't get supported. You're not on a supported version. Not supported, even though, yeah. So you have to keep it updated. And there's an AKS system topic that you can and should connect to in order to be notified by email when there is a new AKS version. So, and then you have to go in and update that Kubernetes version. Know also that potentially the Kubernetes can break your application workload. That has happened. It's not very likely, but it has happened. You should not just blindly say, well, new version, going to just update that thing, just update it and then read it. And in fact, you can just leave your workloads running on there. There will be no downtime. It'll load balance across everything. Update the Kubernetes, all the components running on those nodes, leave your applications on there, should not do that because your applications may break. So that means that you actually have to test out the new versions of Kubernetes and deploy your applications on them before you update your production cluster. That's a task that you have as a Kubernetes operator owner. So you need to have some internal processes for updating, not just the Kubernetes, right? That's just one. The other thing you have to update is, I mentioned all these virtual machines running your containers have an OS image that you do not get to pick, but you do have to keep it updated. Microsoft creates that. It's a version of Ubuntu. We pick it, we patch it, update it, and as a new version every week that you have to update. You don't get to pick any Linux version that you want or just pick one. You get to pick that one. But you have to update it, or Windows. And there's a choice of one, Windows Server 2019. There'll be Windows Server 2022 shortly in the future. They're working on that, right? You'll have to update that too. Those images under those nodes, in addition to the Kubernetes software components on top, because that's the OS image, and then there's the Kubernetes components. Welcome to Kubernetes. You have to update those. Now there is a preview for the node pool images. That's a little bit easier of an automated plan maintenance. That's going to make that part a little less work. Because that part shouldn't break your clusters, right? Because that's the OS. Patching the OSs shouldn't break anything. There's going to be plan maintenance, the images get upgraded. So that part at least is becoming easier. But with the Kubernetes part, still, that part is still on you. Just know that's a thing. Also, you should have some kind of container monitoring security software package. There's a few options from the commercial marketplace, and then there's a Microsoft Defender for Containers service that we offer. Pick one, whichever you want, just have one. Don't have none, which guesses as to whether or not the CLI enables anything. You'd be correct. Nothing. It does not, nothing at all. You should have something like an antivirus checking to make sure that you're do threat protection of your running containers. You should have that. All right. And also the same applies to the images as well. Make sure that you have well, I'm jumping to the last bullet point right here, but you should also have security scanning software, your choice of one, scanning the images that are going to be deployed to your cluster, not just the running versions of those, but the images before they even get there. You should scan the images too. Various choices, pick one. That really hasn't got anything to do with AKS at this point. This is just more of this is the Azure Container Registry, or you can bring your own registry if you would like. Yeah, that's right. There you go. Pull only from authorized registries, authenticate, import any, there you go, third bullet point. Public images into your private registry. So that was your question earlier. Use Azure policy to restrict access to those. We're going to talk about more about Azure policy in a little bit. You're probably familiar with it in terms of the governance that you'd apply all up to your Azure subscription. You can and should also apply it to within the cluster. You're able to control activities that happen inside the cluster, which I think is the only Azure service that policy goes inside the service. There's something as an approximate, there's something similar for virtual machines, but not quite the same. We talked about private link and the need for that, and we talked about security scanning. And now coming on to the Azure policy part that I was coming up. Again, not deployed by default by the CLI. You have to go in and choose to enable this. Now, Josh had some questions earlier about this software component that controls the application gateway. I called it an extension, and there are a variety of extensions. Where the AGIC is one. There are some others that I'm just going to hand wave past, except for this one, which is the Azure policy extension. It's an extension. You need to add software running on your cluster that enables via the familiar Azure policy blade that you might be familiar with to apply governance to how your Azure resources are deployed. And it should have that governance, right? Should be controlled and governed as per the Cloud Adoption Framework. Also is applied inside your cluster. And there's a lot of recommendations that is enabled by this cluster, by this policy. And we have some examples, security baseline for Linux-based, and then some more restrictive ones. You can even bring your own policy. I'll give an example of some of the rules enabled by this policy. Just an example of some of those, and some of them make sense, right? Should be accessible only over HTTPS. So inbound traffic, yeah, that should be only by HTTPS. And ordinarily, you might use Azure policy on top of your application gateways, for example, to enforce that. You could do that. That would break the AGIC, because remember, in this case, Kubernetes is controlling that. So if you apply policy to that application gateway, you'll break the ability of Kubernetes to control it. So you should leave that application gateway alone and instead apply policy to within the cluster. And what that means is that whenever a development team creates, like Josh was asking earlier, a description of their application that uses the AGIC or the load balancer, because it has to have some description of how this application is being accessed, what it does. If that description, this metadata, such JSON, includes HTTP as the ingress, then these policies means that when that developer, or more likely the ADO pipeline, Azure DevOps pipeline, or GitHub tries to deploy the application to the cluster, the deployment will fail. It'll be blocked by policy on the cluster, and then it appears in the Azure policy page as blocked, non-compliant. You'll see a nice friendly error message, and that's how we recommend you govern your cluster. Again, none of this enabled by default. You should do this because it prevents things like it is via this mechanism that, for example, a developer via just creating this description of their application could allow an internet-facing load balancer from my earlier picture, so traffic can hit the cluster directly from the internet on that load balancer. That defies all the security recommendations. Security people get very unhappy, and that's often how we hear about it. This door was left open, right? Very easy to do. One piece of descriptive configuration file from a quick start. We've got lots of them that include this, and it's the default service to use. Internet-facing web application or API, or over HTTP, bang. It is very, very easy to do. And it's ungoverned by default. You have to apply Azure policy to prevent the deployment from happening within the cluster. And there's quite a few of these. Many of these are a bit more weedy, more Kubernetes specific. Won't go into them, but a couple of good ones might be, private clusters, for example, local authentication methods enabled. Hang on, I'll talk about that one. Should have Defender, for example, if that's what you're going to use. External IPs, that's the one that would block internet access and require it via the AGIC, via the application gateway, things like that. There's a few, but anyway, not hard to deploy. Only deploy it once per cluster, and then it's all managed in the usual way, but you have to deploy it. Last step, again, I think I'm beating a dead horse here when I remind everyone guessed that the CLI command I showed earlier does not enable Azure AD integration with the cluster, which is what we'd recommend. Developers or automated accounts should sign in using an account controlled and managed by your Azure AD account in order to get onto the cluster itself. So like you might log in or shell into a virtual machine when you actually get onto the cluster, so you can see the nodes and see the applications running, view the logs, those kind of operation necessary things sometimes. You should control that by Azure, so enable that. And if you don't, there is by default, it's even called a non-auditable backdoor in the documentation. Actually says that is this local accounts feature. So in order to get onto your cluster, to make it really, really easy, one command line, if you put --admin, when you do a command to get the credentials from the command line to get onto your cluster, it'll get in there as admin without, if you have access via your Azure subscription as a contributor, because you created it, which is usually the hub. I created the cluster, and then one command line, I want to get on the cluster, You can do so with one command line, --admin, and you are admin on your cluster. Even if Azure AD is enabled, if you add that later or at deployment time, so it's a non-auditable backdoor into your own cluster. You should close that door. It's open by default. And that means that if you close that door and you haven't enabled Azure AD, you're actually locked out of your cluster. So don't do that. So you have to, which is one of the reasons that is actually there. Yeah, so care is required, but you should enable Azure AD, disable local accounts, and that's how you should log into your cluster. And there's some features of Azure AD, conditional access and just in time. So again, if you're going to log into your cluster, not using the admin credentials, using your Azure AD, you should use conditional access and just in time features of Azure AD as extra auditable steps to control that access to that cluster. And then there is also a capability, some of you are familiar with managed identity, which is, there's two ways of accessing Azure resources. In many cases, not all of them, there's a key that you can use, like a secret, to access a resource, or you can use effectively a service account in Azure AD. And more we're recommending, obviously, Azure AD being the more secure approach for doing that. And Kubernetes actually has support for that from the pod. So you may know that managed identities are supported like at the virtual machine. So a virtual machine can have an account, and then code running on that can act as that account to call other Azure services like SQL Database, Cosmos DB, pull things from a key vault, things like that. That means there are no secrets involved that need to be stored anywhere, and so it's a much more secure approach to providing access from Azure resources to other Azure resources. Kubernetes has a Azure AD workload identity feature that you can and should enable so that your developers, when they're trying to read from their code, Cosmos DB, for example, don't have to put in the whole connection string and store it somewhere that it could get lost or checked into source control. They can and should use this feature right here, similar to managed identity, as a secure, it's basically a system identity that you can apply to a pod, a specific workload of containers, to provide access to those Azure resources. Again, not enabled by default. And also, yeah, and that's one of the things from silos earlier, right? Developers need to know that that's how they should access the resources in Azure. Because if it's not governed and it's not managed, then they're going to use the admin creds to get onto the cluster, and then they're going to use passwords to read, not the strings, keys, to read from storage accounts or key vaults or SQL databases, because they need to access it. And that's a connection string in the most traditional sense, right? And it will work perfectly, but that's not the best practice. Don't do that. Instead, enable these other features and require devs to use those instead. This is why, again, it's important that even developers understand something about the infrastructure, so that, for example, when the policies that I was showing earlier are applied to the cluster, why the deployment fails, right? Why did my deployment fail? My code is bug-free, but somebody broke the cluster. What did they do? Well, we turned on policies so that you can't use HTTP anymore. Use HTTPS. Well, okay, I didn't know. Or whatever it is, right? Use HTTPS. Okay, I use HTTPS. Extra steps, certificates required, more work, but it's what should be done. And again, no governance, it won't happen. If you are going to use secrets in your AKS cluster, there's a couple of ways of doing it. The default normally from Kubernetes is to use this. Kubernetes has some constructs out of the box to just enable this. The developers would Google and find out easily enough how to do it. It ends up storing those secrets on the disks of the nodes, which are encrypted, which isn't bad. That's okay. Better is to have those secrets. If you do it, again, not connection strings, right? These are something other than connection strings, some other secret you might have, or it's connecting to a service that doesn't support Azure AD. MongoDB, for example, in a VM, doesn't support Azure AD, so they need some kind of connection string and a secret for that. A safe place to store that is Key Vault. There's not a need for the developers to get the Key Vault SDKs and make calls directly to that thing. There is, in fact, a driver we provide that we recommend you deploy to your cluster that makes retrieving those secrets no work at all for the developers. But the driver needs to be installed on the cluster, and the developer needs to be told to use it. The infrastructure of the Key Vault is sort of hidden for the developers at this point. No SDKs to install. It's very out of the box experience. Okay, and then the last step actually was one of the first one we talked about. The infrastructure as code, just a general best practice. One of the very first things we talked about don't use the portal to create things. Use infrastructure as code. Check it into the portal, because I think you can see, and the reason why I heard at the end here, what we talked about at the beginning, I'll just reiterate it, is you can see there's a lot of little features and things that should be turned on, configured, switches that should be pulled, and actually in particular governance that should be applied to make sure those switches are pulled and they stay pulled, if you will. Forgive my analogy. And the best way to, well, what did we do to create this? How did we create it, to manage it, to make sure it has everything? Does it have availability zones? Yes or no? Sometimes some Azure services you can't tell by looking at the portal whether it's got availability zones or how the configuration is. You actually have to use the command line sometimes to find out how the configuration is, but you shouldn't need to do that, especially if you created a thing with that infrastructure as code, because you just go read the template used to create it. So all that is to hopefully reiterate the importance of not using the portal and instead using it. And again, I think that ARM was an option. You can certainly use that. Bicep is another. Terraform is a third. I tend to prefer Bicep more these days, but choice is yours. Either one. Yes.
Expose to you all the features.
Yes. Yeah, we do have some recommended starting templates. Right here on this slide right here. So there's a repo. I'm going to put this in this deck in the comments of our meetup today, right? And there's a link right there just to a public GitHub repo. I mean, you know, don't bother remembering it. But I will show it to you real quick. Although, did I miss anything? Oh, okay. The last part I will. Okay, actually two parts before I go on to the infrastructure as code, which is actually the last slide. That's how we close things out, which is infrastructure as code and then CI/CD. So many of you are using DevOps, and this is actually a journey by itself for many customers, right? I've seen customers, you know, the developers hand them, you know, a package, right? The traditional way is make a build, developers a WAR file or an MSI or something, or a container sometimes. Throw it over the wall at the infrastructure team, who then just have to deploy it, following the instructions created by the development team in a very traditional way, and getting to more and more automation, where basically the workloads are automatically deployed to the cluster, which can be done by automation and should follow all of the security best practices. Is a journey. That's not something you just enable, but that is the end goal. And you do have three options of technologies to pick from. We don't have a recommendation on this one. Azure DevOps for those that like it, but know that you need to use a self-hosted agent. So if anyone is using Azure DevOps today, you might be using the Microsoft hosted agents in Azure DevOps. Those will break when trying to use those to deploy your containers to a Kubernetes cluster that has been deployed via our best practices right here. They will not be able to see the cluster because I mentioned right at the beginning, you have an API, the piece that's managed on one of the very first slides that I think you were asking about, some kubectl that we provide as a service. And we recommend, and somebody else had a question on one of the networking slide as to what Josh, I think you asked about it. Yeah, private link enabled. That API, because it's private and can only be seen from that virtual network, means that the Microsoft hosted agents and Azure DevOps cannot see that API endpoint, can't tell the Kubernetes cluster what to do. So those deployments will fail. Now, if you use the CLI, they'll work just fine, because that's why the API is internet facing. But if you lock it down as we suggest, that means that your build agents in Azure DevOps actually need to be on the same VNet as your cluster, or at least have network connectivity over that VNet to your cluster. That can be a bit of a change for some DevOps folks if you're used to using Microsoft hosted agents. It means standing up your own virtual machines, putting private build agents on those VNets. Some installation, some care and feeding on that, and use containers to do that. Some customers do containerize those DevOps agents within the cluster. And
some enterprises choose to put them in a hub. So
Yep, rather than on the spoke. Yep. So yeah, exactly. So some enterprises have that as a centralized service rather than make each dev team go and stand up their own build agents. And it's the same whether GitHub or Azure DevOps. So GitHub would be GitHub Actions, right? Those two will fail if you're not using self-hosted runners, basically VMs running on the same VM. So some enterprises choose, okay, we just have a managed service application team. They give them a corner of their own agents and configure it for the application teams, set all the permissions for them so that it's just ready to go. And then they can use those build pipelines and then that infrastructure sort of as a centrally managed service, if you will. And then you can also do GitOps, which is a pull model. So those first two were push. You're pushing your code. You're telling the Kubernetes cluster what to do. You're sending the code to it or telling it to go and grab a container image, right? GitOps is more of a pull. So it's monitoring your GitHub repo, in that case, polling it. And then when it spots changes, it pulls down all the changes and does all the builds and everything on the cluster. So the fact that it is private isn't a problem because it's pulling. Nothing is trying to push to it. You don't need the DevOps agents. This is Flux. Somebody was asking about that earlier. You were mentioning about Flux earlier, another open source component that forms part of GitOps. Quite a bit of complexity to this third choice right here. A good choice if you have a lot of application teams, different applications sharing one or more clusters, then GitOps can help manage that complexity. If it's one application team on one cluster, GitOps can be kind of a lot of overhead, a lot of work for that, but nonetheless, no, you have options. All right. Okay. And the last thing to call out is something else not deployed by the CLI by default, is a feature, yet another extension gets added to your cluster optionally that is actually, for labeling purposes, considered part of Azure Monitor, the all-up service in Azure. So it's some software that runs on your cluster, this extension, just like the others that we talked about, that is familiar with the way in which your containers in Kubernetes egress logs and telemetry and things like that. And because it is actually running on your cluster, has a great deal more access to the telemetry and logs of your containers because it's right in there. It grabs all that up and then it sends it out to a log analytics workspace where you can then, it provides views and dashboards so that you can, your development team can then get the telemetry that they would want about how their code is running, applications, logs, all the usual things without actually having to connect to the cluster at all, which is the normal way they would have to go and get those logs. Actually have to kubectl into the cluster and run native Kubernetes commands to see how their pods are doing, things like that. There's no need for that. They can just see it all if you enable monitor containers via the portal. Slice and dice it, alert upon it, lots and lots of features because the data, the telemetry is all scooped up and sent outside the cluster to a log analyst workspace. So very, very powerful feature, not enabled by default. That's in addition to application insights, which some of the developers might be familiar with, which is a more developer-centric feature of Azure Monitor. This is, specific to knowing how containers work. That was the point there. Application insights is additional feature of Azure Monitor that really has nothing much to do with AKS at this point. Okay, so we will then go on to the last slide. I'll just show everyone it because it's been very popular. So a team of colleagues on my side have created this. Again, I'll put the link it's in the deck, but so this guy. So this is a whole accelerator. It tells you all about it, what it does, and there's a diagram here. I'll try and. Yeah. So this diagram should look familiar. It's a lot like some of the others, right? So we have on the right side this time, we have a hub with a firewall and an Azure Bastion, all created NSGs, and then VNet peering. So this is a VNet. There's another VNet peering right here to another separate VNet. They're joined together with an AKS cluster deployed to it. So this is your landing zone right here. And then supporting components in a subnet different from the AKS cluster. The ones we just talked about, Azure Container Registry, all connected via private link, Key Vault connected via private link, and an application gateway with AGIC deployed onto the cluster. So it's controlling it. It has all the features, all the, with the exception actually of the zones is actually the only component. This is a security focused deployment. So it skips the zones, high availability and scaling capabilities that we talked about, but it includes all the security ones. So the extensions that we talked about, the policy extension, it walks you through deploying that, the AGIC, all of those private endpoints for the API, all of it is in here. There's a whole bunch of scripts, step by step. Here's what it creates. It picks Azure CNI, like we talked about, as we recommended. Azure Monitor for Containers, we just talked about that. And it'll actually, if you walk it all the way through, it puts an example, it walks you through deploying an example application to it, which will use some of the components we talked about. The secret store. This is the component that exposes a key vault to developers in an easy way for them to store secrets. And it has an application that shows you how to do that, uses Azure AD, pod managed identities, the whole kit and caboodle. They're going to add some of the auto scaling features that we talked about. We recommended that's coming, as well as they're going to use some of the other services as the example workload if you want. So yeah, Mark was just saying we've got 3 different options here. My personal favorite is the bicep, but up to you, whatever floats your boat, right? And it steps you through, first of all, creating some groups in Azure AD. Then it walks you through creating the hub, which has the firewall, the landing zone, which is the spoke, the supporting services, which is a key vault, and the Azure Container Registry and private link, and then the cluster itself, 07. And then there is an 08, actually, yeah, so wait, the cluster itself is 06, and there is a step 7 if you want, which is deploying an example workload in containers, so you can see the whole end-to-end. You actually deploy some containers on there, configure them, and get it all up and running through the application gateway. So it uses that thing. With HTTP. Sorry, second.
You help develop this?
This I actually did not help develop. Actually, yes, okay, I did. Yeah, I did. I've helped build this out. Yeah, I didn't do most of the work. That's why I hesitated. I helped, but other teams have done most of the work. I've walked quite a few customers through doing this right now, and we've improved it actually based upon that experience of literally walking teams through all of this every time they stubbed their toes and learnings and all of that, and made it better and incorporated everything. So you follow these steps, and that AKS cluster I showed you at the beginning right here was created with running these scripts. Yeah, it will take you 4 or 5 hours the first time, maybe, just slowly stepping through each piece without interruptions, every little bit, because there's some, yeah, there's some steps. There's some waiting too. You have to wait for the application gateway to come up. Takes 10-15 minutes. There's a firewall, takes another 10-15 minutes. A little bit of waiting and stepping through it. But yeah, I can now do it. I can run it in 10-15 minutes. Kick through the whole thing with the waiting. So, okay, it's implemented if we look at how it's actually done. You had a question at the far end though, sir.
If I was trying to get support out of this one, do they have to get a fast card on it, or do I have to just go to the repo and ask for help, or edit the tickets?
Yeah, you can put it. No, this is not supported by Microsoft, right? This is community. So no, you need to put a ticket. What we'd love is we'd love pull requests. So if you find something, find the solution to it and fix it, that would be great. We welcome pull requests. Thank you for helping it. On Azure, yep. Mm-hmm. Yep. So to answer your question around the steps, they're actually, let's see, So let's see, pick creation of AKS, this one right here, steps you through it, change the directory, and there's the answer to your question. So you run Azure CLI commands, AZ feature register, and then the actual deployment is done via, let's see, like this one, that line there, Azure deployment sub create. That right there actually runs the infrastructure as code. That's actually what that command does. Now the code, it refers to it, in your local directory right there. That assumes that this bicep file, which is in this repo, and it walks you through it. It walks you through how to do it. You're cloning, you make a copy of these files in this GitHub repo to your local disk of your machine, and then run this AZ command, which will refer to those files on your machine, some of which you may choose to edit if you want to name things, and some of which you will need to edit them a little bit because some of it is going to be unique to your environment, right? So yeah, it's these parameter files right here. So you'll edit those guys in Notepad or something. Again, it walks you through it. It walks you through it, and you can change the names of things if you want, or go with the defaults. And then yeah, you run this line, and that's what deploys all the infrastructure as code. This is the AZ command, works on Windows or Linux, or if you're a PowerShell person, you can use PowerShell. Either way, it's using the same files, as you can see, main.bicep right here in the region that you want. Pick a different region if you want, like so.
Adam,
yes.
Is there a CDK equivalent in the Azure space for configuration of Azure services as well as AKS?
A what equivalent? Sorry.
The AWS CDK, the equivalent of that for Azure and AKS.
I don't know what the AWS CDK is.
It's
is that like the command line? Is that? It's McKenna speaking. Hey, McKenna.
Yeah. Hey. Cool. It's IAC using different languages. So it just compiles to JavaScript or TypeScript. Okay. But you can code in C# and Python and whatever else. So
okay. Well, I mean the CLI that I was showing you on the screen just now it is open source, so you can read that if you want. But all that does is wrap the Azure APIs, which are public, the same as the PowerShell commandlets wrap the APIs. So if you wish, you can actually call the APIs directly yourself. So I think that's those are the offerings we have. Doesn't sound like there is one quite like what you described. Right. Yeah, the closest would be calling the APIs directly, or pick from the Azure CLI we just talked about, the command line interface, or PowerShell commandlets, both of which are downloadable. Yeah.
Yeah. Thanks.
Yeah.
So how does it fit with Hadoop implementation?
Repeat the question, Anna. If it runs on containers, Windows or Linux, then you pick the right node pool, and it can be deployed on that. Yeah. Mm-hmm. Yeah. So so whatever you. Yeah, that's the beauty of containers. Okay. If you can get it to build to a container, Windows or Linux, then and you have a node pool of Windows or Linux, then your container will deploy.
Can't talk to
yeah, but at that point, all the container is a place where your code runs, right? That looks like it's on its entire server all to itself, to your code. That's all it is. And the code can be whatever you want. Perl, Python, .NET, some crunchy old thing, as long as it runs on the chip architecture of the nodes that you're running it. Then you'll just pick the Linux or Windows flavor accordingly, and then if your code can talk out, it can see out to the internet. I mean, and that's configured by the hub and spoke that we showed earlier. So the traffic is your application can just talk to whatever.com. And if the rules on that firewall are configured to let it out, which they're not by default, they're added, then it can see out. If that's again the purpose of the hub and spoke. Right? your application, your Kubernetes, it doesn't care. It's just going to let traffic egress through it. But you should manage the traffic between nodes via those policies we talked about. Egressing traffic is just out it goes, and then something else needs to deal with it. That's why we have the hub and spoke. So if it's talking to, another SQL server or Hadoop. Yeah. So as long as you, so it depends if your Hadoop cluster is internet facing, then you just need to allow the route, you don't have to do anything to the Kubernetes cluster. Just configure the URL, an environment variable, and have the code call it. However, if it's running on virtual machines, right, then there needs to be network connectivity to those virtual machines. So they'd be on another spoke, typically. Another spoke. So again, just DNS would manage it. Again, Kubernetes doesn't care. Your workload will talk to a 10 dot instead of an internet-facing IP address. Again, Kubernetes couldn't care less.
So you have option to configure your virtual machines.
The nodes of the Kubernetes cluster?
Yeah.
You do. I should stand nearer the microphone right here. I was actually going to go get some water. But I'll answer your question. Yes, you can configure disks on the virtual machines. You get enough for you. Last one. Yes, they're just regular virtual machines, right? So yeah, you can add disks to those things, and you pick between premium and SSDs, and you've got the usual virtual machine constructs, but don't do that. That was I didn't go into sort of that level of weeds actually, but so your cluster should be stateless, generally speaking. So you are able to write stuff to the disks of those nodes if you want, but then you've got state that's local to the cluster, and then you've got a way you have to manage getting it between nodes. How does a pod over here on this VM talk to the, and then it becomes hell. So don't store any state at all on the cluster at all. All the data store, whatever you might need, database, file system, you need to write to a file system, mount a share from Azure files to your cluster and have your code just talk to that. Yeah, and we actually prefer, there's actually connectors to make that easy. So that's native. So that's easy to do. Is to mount a file share. It's native to Kubernetes. Easy peasy. Create the thing. Use private link to tie it to the VNet for security, and then your code just talks to a file share as if it's just expects to be there. And then it's outside of the cluster, right? So as nodes scale in and out, and things break and whatever, your data is all outside of it. Delete the whole cluster, the state's still outside. So that's why I say don't use disks on the virtual machine unless they're very high performance scratch disks. That's a use case. You might, so super SSDs, you might need that.
So you can, when you spin up nodes, you can do a lot of your own customized
you get to pick the VM SKU, right? And reasons for that might be so confidential computing. So there are capabilities of certain Intel chips that we've enabled that you can write code in SDKs for to have processing done on the chip in a secure place, right? You need special hardware for that. So you can have Kubernetes node pools of that VM type if that's hardware. Similarly, GPUs. You've got application that has a NVIDIA SDK that knows how to talk to GPUs and do lots of math. Then you can pick virtual machines as your node pools that have GPUs in and deploy your containers to those. You can configure the disks, lots of disks if you want, the size of the disks, how big they are, how fast they are, number of cores, lots of control. Yeah, that's true. Accelerated networking as well. So very high performance connectivity from your node to other nodes if you want. Yeah. Yes, sir. Last question.
Have you heard of the AKS deploy helper? Part of the AKS constructor repo in the Azure.
I sure have. Yes, that is a lot better than the command line that I described, and includes a lot of the best features. It spits out a little command line, a little AZ command line that has a lot of the features we talked about. Problem with that is that it's not infrastructure as code. So it is better.
CLI.
Yeah, it's CLI. Yeah, it's CLI. So it is better. It's better than the example I showed. But the reason I didn't suggest looking at that one is because what you should really use is infrastructure as code to define how it is. And just use the CLI to deploy your infrastructure as code. What that example shows is CLI to deploy the entire infrastructure, which
You can use that to build the CLI and convert it into a template to use in the future. Yes, you got all primary.
yeah, it's better. It's definitely better, but not as good as the example that I was on this GitHub repo. That's infrastructure as code. That's the way to do it. Yeah. All right. I mean, that concludes it. There's any more questions? We've got still a few folks online. Very brave souls still there. McKenna had a question. No others from online. You can unmute your mics if you have any, like McKenna did. But if not, then that concludes this month's Azure Meetup. Did anyone learn anything? Yeah, me too. Thank you. Next month, Michael is going to be our speaker at the back there, talking about. Okay, we'll post that one. It's going to be in a couple of weeks. Going to be back in here, so I'll get to learn something from that one. So, thank you all for coming out. It was great to see some familiar faces back in person and meet some new faces too. Thank you all for coming out. Grab some pizza. We won't let it go to waste. The building folks tend to take it off of our hands. We'll take it down to them. But please, if you'd like to take some, please help yourself. You know, that would be cool. But otherwise, yeah, thank you, and hope to see you here next month. Thank you.
Thanks again for your high energy.
Oh, you're welcome. I enjoy myself a lot. Thank you, folks, everyone online. I'm going to close out the call now. Hope this was useful.